The silence before memory. The world ended in water. Not slowly, not with warning, but in a single catastrophic moment when the sky itself seemed to tear open, and the oceans rose from their ancient beds, like hungry gods awakening from forgotten sleep. The year was 12,000 before the birth of Christ, though no one who lived through those final days would survive to mark the calendar or remember the counting of seasons. They knew only that the world they had built across millennia was dissolving beneath waves taller than mountains, beneath rain that fell like stones, beneath winds that screamed with voices older than human memory. But before the waters came, before the sky darkened and the earth shook itself apart, there was magnificence. There was a civilization so advanced, so impossibly sophisticated, that even now, across the vast chasm of 14,000 years, we struggle to comprehend what they achieved. They built cities that would make our modern metropolises look like crude approximations of urban planning. They carved monuments from stones that weigh more than 100 of our largest vehicles combined, fitting them together with such precision that even today a blade cannot slip between their joints. They possessed knowledge of astronomy that would not be rediscovered for 10,000 years. They understood mathematics that our ancestors would struggle to reinvent in the shadows of Greek philosophy and Arabic numeracy. And then, in what seems like a single, terrible night, they vanished. The story begins not with certainty, but with whispers. Whispers carried across continents in the myths of peoples who never knew each other, who lived separated by impassable oceans and impenetrable jungles, yet somehow told the same story. The Greeks spoke of Atlantis, the island nation that sank beneath the waves in a day and a night of catastrophe. The Sumerians recorded tales of cities swept away by divine flood. The Maya preserved stories of previous worlds destroyed by water and fire. The Aboriginal peoples of Australia maintained oral traditions spanning tens of thousands of years, speaking of times when the coastlines were different, when great lands existed where now only ocean rolls. These were not primitive superstitions. They were memories. Imagine standing on the edge of the world as it existed 14,000 years ago. The planet you would see bears only passing resemblance to the one we know today. The continents themselves wore different shapes. What we call the Mediterranean Sea was once a vast, fertile valley, dotted with cities and crossed by rivers that no longer exist. The Persian Gulf was dry land, a green paradise of flowing water and abundant life. Indonesia was not an archipelago, but a massive subcontinent called Sundaland, larger than modern India, connected to mainland Asia by forests and plains where now only scattered islands remain. The oceans were lower then, dramatically lower, because the world was still locked in the grip of the last great ice age. Massive glaciers covered the northern continents, sheets of ice miles thick that held in frozen suspension water that would have raised the sea levels hundreds of feet. The shorelines existed dozens, sometimes hundreds of miles beyond where they are today. And it was along these ancient coastlines, now drowned beneath the waves, that some of the most advanced centers of human civilization flourished. They understood the stars with an intimacy that seems almost impossible for people who possessed no telescopes, no computers, no satellites. They tracked the precession of the equinoxes, that slow wobble of Earth's axis that takes nearly 26,000 years to complete one cycle. They knew about celestial mechanics that would not be rediscovered until the Renaissance. They aligned their monuments with astronomical precision, encoding in stone the movements of celestial bodies across time frames that spanned thousands of years. How did they know these things? The question haunts us because we have been taught to believe that human civilization began merely 6,000 years ago in Mesopotamia, that everything before was simple hunter-gatherers living in caves, scratching pictures on walls, and barely surviving. We have been told that writing was invented around 3000 BC, that sophisticated architecture emerged around the same time, that mathematical and astronomical knowledge gradually accumulated from that point forward. But the evidence that has emerged in recent decades tells a very different story. It speaks of a forgotten chapter in human history, a civilization, or perhaps multiple related civilizations, that achieved heights we are only now beginning to recognize. The proof exists not in written records. Those were swept away by the waters, but in stone, in monuments so massive and so precisely constructed that they have survived the millennia, while everything else crumbled into dust. Consider the Great Sphinx of Egypt, that enigmatic monument that guards the Giza Plateau with its eroded, weathered features, gazing eternally toward the rising sun. Egyptologists have long claimed it was built around 2500 BC by the pharaoh Khafra, carved from the limestone bedrock in honor of royal power. But examine the Sphinx more closely, and a disturbing pattern emerges. The weathering on its body does not match the weathering patterns of other structures definitively dated to the Old Kingdom period. The erosion is deep, flowing, vertical. Not the kind created by wind and sand, but by water, by rain, by substantial, persistent rainfall over extended periods. Egypt has not experienced that kind of rainfall since the end of the last ice age, around 10 to 12,000 years ago. The implications are staggering. If the Sphinx shows water weathering, and if Egypt's climate has been arid for the past 10,000 years, then the Sphinx must be far older than conventional history suggests. It must date to a time when Egypt was green and wet, when rivers flowed and rains fell, when the Sahara was not a desert, but a savanna teeming with life. A time that orthodox archaeology claims no advanced civilization existed. Yet there it sits, massive and mysterious, its true age written in the language of erosion that only the earth itself can speak. Move across the planet to the coast of Lebanon, to the temple complex of Baalbek. Here, in the foundation of what would later become a Roman temple, lie the largest worked stones ever moved by human hands. The 3 stones of the trilithon weigh approximately 800 tons each. 800 tons, that is roughly the weight of 3 fully loaded Boeing 747 aircraft, except carved from solid rock, transported several miles, and lifted into place with such precision that their surfaces align perfectly despite their enormous mass. Our modern construction capabilities struggle with loads this size. The largest cranes we possess can lift perhaps 1,000 tons under ideal conditions, using advanced hydraulics, computer controls, and decades of engineering knowledge. Yet somehow, at a time when humans supposedly possessed only copper tools and wooden rollers, someone moved these megalithic blocks and positioned them with perfect precision. The Romans who later built atop these foundation stones were so awed by them that they did not even attempt to claim credit for their construction. They called the site a work of giants, of divine builders from an earlier age. And perhaps, in their own way, they were closer to the truth than they knew. Travel to the high plains of Peru, to the mysterious ruins of Pumapunku. Here, scattered across the windswept plateau, at nearly 13,000 feet above sea level, lie the shattered remains of a complex that defies explanation. Enormous blocks of andesite and diorite, stones so hard they can barely be worked even with modern diamond-tipped tools, are carved with perfect right angles, smooth surfaces, and intricate interlocking geometries. The precision is remarkable. The surface is flat to within fractions of a millimeter, the corners meeting at exactly 90 degrees. These are not stones that were roughly shaped by primitive tools. These are precisely machined surfaces, created with a level of accuracy that suggests advanced knowledge of geometry, sophisticated measuring instruments, and techniques we cannot even definitively identify. Some blocks show signs of having been cast rather than carved, as if the stone itself was somehow softened, poured, and molded like concrete, a technology that should not have existed in ancient South America. The conventional dating places Pumapunku at around 1,500 years old, but this dating relies on organic material found in the vicinity, not on the stones themselves. Stone cannot be radiocarbon dated, and local traditions among the Aymara people speak of the site as already being ancient and ruined when their ancestors first arrived in the region. They say the city was built by the gods in a single night, before the great flood that destroyed the old world. The flood again. Always the flood. Every culture on earth preserves some version of this story. The Judeo-Christian tradition knows it as Noah's Ark and the 40 days of rain. The Mesopotamians recorded it in the Epic of Gilgamesh, where the hero Utnapishtim survives the deluge sent by the gods. The Hindu Vedas tell of Manu, warned by a fish to build a boat before the waters consumed the world. In China, the story of Gunyu describes a great flood that took generations to control. The Hopis speak of the destruction of the Third World by water. The Aztecs preserved accounts of the age destroyed by flood, before the current fifth sun arose. These are not variations of a single story that spread from one source. These are independent cultural memories of an actual event, preserved through oral tradition across thousands of years, maintained by peoples separated by vast distances and impenetrable barriers, who nonetheless remember the same catastrophe. Something terrible happened to the Earth around 12,000 years ago. Something that destroyed coastlines, buried cities, and nearly extinguished human civilization entirely. The geological record confirms it. Deep in the ice cores drilled from Greenland and Antarctica, in the sediment layers at the bottom of the ocean, in the fossilized remains of creatures that went extinct suddenly and completely, the evidence exists of a global catastrophe that struck at the end of the Younger Dryas period. This was a sudden, violent climatic shift that saw temperatures plummet, then spike upward with terrifying rapidity. Sea levels rose by hundreds of feet in a matter of centuries, sometimes even decades. Massive extinctions swept across continents. Entire species of megafauna, woolly mammoths, giant sloths, saber-toothed cats, vanished in what appears to be a geological instant. What could cause such devastation? The theories are many and contested. Some researchers point to volcanic supereruptions that filled the atmosphere with ash and triggered rapid climate change. Others suggest massive earthquakes triggered by the weight of melting glaciers, unleashing tsunamis that reshaped coastlines. Some propose that a comet or asteroid struck the Earth, perhaps fragmenting in the atmosphere and raining destruction across multiple continents simultaneously. Recent evidence has emerged of platinum anomalies in soil layers dating to this exact period, platinum being an element far more common in cosmic bodies than in Earth's crust, suggesting extraterrestrial impact. Whatever the cause, the effect was unambiguous. The world that existed before 12,000 BC was largely destroyed, and with it vanished a civilization, or civilizations, that had achieved remarkable things, leaving behind only fragments, only hints, only monuments too massive to be completely erased by the catastrophe that consumed everything else they created. But who were they? What did they call themselves? What languages did they speak? What stories did they tell their children? What dreams filled their nights, and what fears haunted their days? We do not know. We cannot know. The waters took their libraries, their cities, their written records, their art, their poetry, their music. Everything organic rotted away long ago. Everything that made them fully human and individual has been lost to the abyss of time. What remains are only bones, not literally, for even most of those have dissolved, but metaphorical bones, the skeleton of their civilization, preserved in stone and myth, and the faintest echoes of remembered knowledge. Yet even these fragments are enough to hint at something extraordinary. They suggest that human history is far older, far more complex, and far more mysterious than the neat timeline presented in textbooks would have us believe. They whisper of capabilities that should not have existed, of knowledge that could not have been attained, of achievements that mock our assumptions about the linear progress of civilization. Perhaps most tantalizing of all, they raise the possibility that we are not the first technological civilization to arise on Earth, that before our current chapter of human development began in the ancient Near East 6,000 years ago, there was another chapter, now mostly erased, where different peoples achieved different kinds of greatness, and that the fall of that earlier civilization, preserved in the flood myths of every culture, represented not just a natural disaster, but the end of an entire epoch of human achievement. The evidence is scattered across the planet, hidden in plain sight, yet overlooked by conventional scholarship that clings to established timelines. It exists in the massive stone blocks that should not have been movable with primitive technology, in the astronomical alignments that demonstrate sophisticated knowledge of celestial mechanics, in the mathematical precision of architectural designs, in the global distribution of similar symbols and similar techniques, in the persistent myths that speak with one voice about an advanced people destroyed by cataclysm. Stand at the base of the Great Pyramid of Giza and look upward at the more than 2 million limestone blocks, each weighing several tons, fitted together with precision that leaves gaps smaller than a razor blade. Consider that this structure was supposedly built in merely 20 years, which would have required setting one block every few minutes, 24 hours a day, for 2 decades straight. Consider that its base is leveled to within fractions of an inch, despite covering more than 13 acres. Consider that it is aligned to true north with accuracy that rivals our modern constructions using GPS and laser transits. Then ask yourself whether this is really the work of people who had only just invented the wheel, who worked by torchlight and copper chisels, who possessed no written mathematical texts and no engineering tradition to draw upon. Or consider whether this monument, like others around the world that share suspicious similarities, might be the work of survivors, the remnants of a more advanced age, people who carried within their minds the memories of what had been lost, attempting to preserve in stone the knowledge that could no longer be written in books or taught in schools that no longer existed. Perhaps the pyramid was not meant primarily as a tomb. Perhaps it was a message, encoded in proportion and alignment, designed to survive millennia and communicate to distant descendants that there was greatness before, that humanity had achieved wonders, that we should not forget. The ancient Egyptians themselves insisted they were not the originators of their civilization, but rather the inheritors. Their own texts speak of the Zep Tepi, the first time, an age of gods and wisdom far in the past, when the foundations of their culture were laid. They spoke of knowledge given to them by those who came before, by the mysterious Shemsu Hor, the followers of Horus, who brought civilization to the Nile Valley from some unknown origin point. Who were these followers of Horus? Where did they come from? The texts do not say, or if they did, those texts have not survived. But the implication is clear. The Egyptians themselves believed their civilization was a renaissance, a rebuilding of something that had existed long before, an attempt to recapture lost glory. The same pattern appears in other ancient cultures. The Sumerians spoke of the Apkallu, the 7 sages who emerged from the sea before the flood to teach humanity the arts of civilization. The Mayans told of Kukulkan, the feathered serpent who brought knowledge from across the ocean. The Vedic traditions of India describe the rishis, enlightened beings from an earlier age who preserved wisdom through the cycles of destruction and rebirth. Always the pattern repeats. Knowledge from before, teachers from elsewhere, wisdom preserved from an earlier time. These are not creation myths in the usual sense. They are cultural memories of actual transmission, actual preservation, actual attempts to maintain and rebuild after catastrophic loss. And if we accept this possibility, that human civilization is far older than we thought, that an advanced culture existed before 12,000 BC and was largely destroyed by a global cataclysm, then we must also confront an uncomfortable question. What else have we forgotten? What other knowledge was lost? What capabilities did they possess that we have not yet rediscovered? The ancients seem to have understood acoustics in ways we are only beginning to appreciate. Many megalithic chambers around the world demonstrate remarkable acoustic properties, resonating at specific frequencies that can induce altered states of consciousness, or carry sound with perfect clarity. The temples at Malta, the chambers beneath the pyramids, the galleries at Stonehenge all show evidence of sophisticated understanding of how sound behaves in enclosed spaces, how particular frequencies affect human neurology, how architecture can be designed to amplify or dampen specific wavelengths. They understood astronomy well enough to track and predict celestial events across millennia. The Antikythera mechanism, that corroded bronze device pulled from a Mediterranean shipwreck, dates to around 2,000 years ago, but demonstrates mechanical sophistication that would not be matched again until the Renaissance. It is an astronomical calculator of stunning complexity, using dozens of precisely cut gears to predict the positions of celestial bodies. the timing of eclipses, and the cycles of ancient calendars. If such a device could exist 2,000 years ago, what existed 4,000 years before that? What computational devices might the pre-flood civilization have possessed, now lost to rust and rot? They may have understood electrical phenomena. Strange artifacts have been found in Iraq that resemble primitive batteries, clay jars containing copper cylinders and iron rods that, when filled with acidic solution, can generate electrical current. These Baghdad batteries date to around 2,000 years ago, yet Orthodox history claims electricity was not understood until the 18th century. Were these isolated experiments? Or were they crude recreations of older technology? Attempts to reproduce devices whose principles were half-remembered from earlier times. Some researchers have suggested the ancients possessed methods of manipulating stone itself, perhaps using sound frequencies or chemical treatments to temporarily soften rock, making it malleable, and allowing for the precision shaping we see in megalithic constructions. This seems impossible by modern chemistry, yet the evidence of precision that rivals or exceeds our current capabilities remains undeniable. How else to explain the perfectly flat surfaces on stones that predate metal tools? How else to account for the intricate geometries carved into materials too hard to be worked with copper and bronze? Perhaps most controversial of all, some researchers have suggested the ancients possessed methods of flight. This suggestion draws fierce criticism from mainstream academia, yet curious evidence persists. The Nazca lines in Peru make little sense unless viewed from the air, yet supposedly were created by people who had no ability to fly. Ancient Indian texts describe vimanas, flying machines used by the gods in elaborate aerial battles. The Egyptians depicted strange objects in their hieroglyphs that bear resemblance to helicopters and aircraft. The ancient Sumerian texts speak of the Anunnaki, descending from the heavens in craft that roared like storms. Are these merely mythological flights of fancy? Metaphors for spiritual ascension? Or distorted memories of actual capabilities that once existed? We cannot know with certainty. The flood took too much. Time buried the rest. What remains are only these fragments, these whispers, these monuments that should not exist, yet undeniably do. But perhaps that is enough. Perhaps these fragments are sufficient to inspire us to look deeper, to question more thoroughly, to abandon the comfortable assumption that history is a simple linear progression from primitive to advanced. Perhaps we need to consider that history is cyclical, that civilizations rise and fall, that knowledge can be lost as well as gained, and that the story of humanity is far longer and far stranger than we have been taught to believe. The people who built the impossible monuments, who possessed the inexplicable knowledge, who left their mark in stone across every continent, they were human, just as we are human. They were not gods, not aliens, not supernatural beings. They were men and women who lived and loved, who struggled and dreamed, who built their cities and raised their children and looked up at the same stars we see tonight. But they knew something we have forgotten. They remembered something we have lost. And perhaps, encoded in the monuments they left behind, preserved in the myths they passed down through countless generations, hidden in the very structure of the mysterious constructions that dot the ancient world, That knowledge waits for us to rediscover it. The question is whether we are ready to listen, whether we are willing to look past the boundaries of conventional history and consider possibilities that challenge everything we think we know about human origins and human capabilities. Whether we have the courage to admit that our ancestors might have been far more sophisticated than we give them credit for, and that by dismissing their achievements as impossible, we might be losing our last chance to recover wisdom that could benefit us all. The architecture of impossibility. The sun rises over the Giza Plateau as it has risen for thousands upon thousands of mornings, casting long shadows across the desert sand and illuminating the three great pyramids that stand as silent witnesses to ages beyond memory. But today, as every day, tourists and scholars alike gather to marvel at these structures without truly comprehending what they represent. They see monuments. They see tombs. They see ancient engineering projects completed by human determination and slave labor. They do not see the impossibility. Stand before the Great Pyramid and attempt to fathom what it truly represents. This is not merely a pile of rocks arranged in a pleasing shape. This is a structure that contains approximately 2.3 million limestone blocks, each averaging 2.5 tons in weight, with some interior granite blocks weighing as much as 80 tons. The mathematics alone stagger the imagination. If we accept the conventional timeline that claims this pyramid was built during the 23-year reign of Pharaoh Khufu, then workers would have needed to quarry, transport, dress, and position one block every 2 to 3 minutes, working without pause, day and night, for more than 2 decades. Consider what that means in practical terms. Every few minutes, a block weighing as much as a large automobile would need to be moved into position with precision measured in millimeters. This would need to happen in darkness as well as daylight, in the blazing heat of summer and the relative cool of winter, without interruption, without significant error, for 23 consecutive years. The logistics are nightmarish, even with modern equipment. With only copper tools, wooden sledges, and human muscle, they become essentially impossible. Yet the pyramid stands. Undeniably, impossibly, it stands. The precision of its construction mocks our assumptions about ancient capabilities. The base of the pyramid forms a nearly perfect square, with sides measuring approximately 756 feet in length. The difference between the longest and shortest sides is less than 2 inches, an error of less than 0.1%. The base is level to within a single inch, despite covering more than 13 acres of desert bedrock. The 4 corners align to the cardinal directions, north, south, east, and west, with an accuracy of less than 4 minutes of arc, a precision that would not be matched again until the age of precision instruments and surveying equipment. How did they achieve this? How did workers using primitive tools manage to level a foundation covering 13 acres to within an inch? How did they align the structure to true north with precision that equals or exceeds what our modern instruments can achieve? We struggle to answer these questions because the mathematics and engineering required exceed what should have been possible for a civilization that had supposedly only just emerged from the Stone Age. But the precision goes deeper still. The pyramid embodies sophisticated mathematical relationships that suggest knowledge far beyond what conventional history attributes to ancient Egypt. The ratio of the pyramid's perimeter to its height equals 2 times pi, the same ratio as a circle's circumference to its radius. This is the mathematical relationship that describes a circle, encoded in stone by people who supposedly had not yet discovered pi as a mathematical constant. The ratio appears not once but repeatedly throughout the structure's design, suggesting not coincidence but intentional incorporation of advanced mathematical principles. The pyramid sits at a location that represents exactly 1/3 of the distance between the equator and the North Pole. Its latitude in degrees, 29.9792, corresponds almost exactly with the speed of light in meters per second, 299,792,458. This cannot be intentional, skeptics say, because ancient Egyptians could not have known the speed of light or the exact dimensions of the Earth. Yet there the number sits, encoded in the pyramid's position, impossible to dismiss as pure coincidence, given the many other mathematical relationships the structure embodies. The weight of the pyramid, calculated by multiplying its volume by the density of limestone, equals approximately 5.9 million tons, which happens to be exactly 1/1000th of the mass of the Earth. Again, skeptics insist this must be coincidence. Ancient peoples could not have calculated the Earth's mass, yet the ratio remains. One more impossible detail in a structure filled with impossibilities. Move inside the pyramid, into the grand gallery that leads to the king's chamber, and the precision becomes even more remarkable. This ascending corridor rises at an angle of 26 degrees, its walls corbelled inward in 7 overlapping layers that create a ceiling nearly 30 feet high. The surfaces are smooth, the angles consistent, the whole corridor rising through the heart of millions of tons of stone without visible support or structural weakness, even after more than 4,000 years. At the top of the grand gallery lies the king's chamber, a rectangular room constructed entirely of red granite blocks, each weighing dozens of tons, transported from quarries 500 miles away at Aswan. The chamber's dimensions follow precise mathematical ratios. Its length, width, and height conform to proportions that create specific acoustic properties, causing the room to resonate at a frequency of approximately 116 Hz, a tone that modern acoustic research has shown can induce altered states of consciousness in human beings. Was this chamber really designed as a tomb? If so, why build it with such acoustic precision? Why construct it from granite rather than limestone, when granite is far harder to work and far more distant to source? Why create a space that seems designed not for burial, but for some kind of ritual or process involving sound and resonance? The sarcophagus that sits in the king's chamber raises its own questions. It is carved from a single block of red granite, hollowed out with precision that defies explanation. The interior corners are perfectly square. The walls are of uniform thickness. The whole object rings like a bell when struck, suggesting it was tuned to a specific frequency. Yet this remarkable artifact supposedly was created by craftsmen using copper tools and stone pounders, despite granite being one of the hardest stones known, nearly impossible to work without advanced metal tools or diamond-tipped equipment. Conventional Egyptologists explain these achievements through simple persistence and massive labor forces. They point to ancient Egyptian paintings showing large numbers of workers hauling stones on sledges, pouring water on sand to reduce friction. They suggest that given enough time and enough people, almost anything becomes possible. But this explanation grows less satisfying the more one examines the actual evidence. Consider the granite blocks in the King's Chamber. Each weighs between 25 and 80 tons. They had to be transported 500 miles from the Aswan quarries, loaded onto barges, floated down the Nile, unloaded, dragged across the desert, and then lifted more than 300 feet up into the growing pyramid structure and positioned with millimeter precision. The conventional timeline allows only about 23 years for the entire pyramid's construction, meaning these massive granite blocks had to be quarried, transported, and positioned alongside all the limestone blocks that form the bulk of the structure. The logistics strain credulity. Even if we accept that the ancient Egyptians possessed sophisticated construction techniques not yet recognized by modern archaeology, the timeline remains problematic. The precision remains unexplained. The mathematical sophistication embedded in the design suggests knowledge that should not have existed in the 3rd millennium BC. Unless, of course, it was not knowledge newly developed in the 3rd millennium BC. Unless it was knowledge inherited from an earlier time, preserved through catastrophe, maintained by survivors who remembered a world before the flood. Travel now across the planet to the other side of the world, to the ancient site of Göbekli Tepe in modern Turkey. Here archaeologists have uncovered a complex that shatters all conventional understanding of human development. The site consists of massive stone circles made from T-shaped pillars, some weighing more than 10 tons, carved with intricate reliefs of animals and abstract symbols. The circles are arranged with astronomical alignments and architectural sophistication that demonstrates advanced planning and execution. The shocking part is not the sophistication itself, but the date. Göbekli Tepe is not 3,000 years old like the pyramids. It is not 5,000 years old. It is somewhere between 11 and 12,000 years old, placing its construction right at the end of the last ice age, right at the time when the great flood myths describe the destruction of an earlier world. According to conventional archaeology, humans at this time should have been primitive hunter-gatherers, living in small nomadic bands, possessing no agriculture, no permanent settlements, no capacity for large-scale construction projects. Yet here stands Göbekli Tepe, requiring organizational capabilities, engineering knowledge, and mathematical understanding that should not have existed for another 6,000 years. The site was deliberately buried around 8,000 BC, filled in with carefully placed rubble, as if someone wanted to preserve it intact for future discovery. Who buries a temple complex that required enormous effort to build? Why abandon and entomb such a remarkable achievement? Perhaps because the people who built it were leaving, dispersing, carrying their knowledge to new locations as they fled rising waters and climatic catastrophe. Perhaps they buried it as a time capsule, a message to the future that sophisticated civilization existed long before history remembers. The pillars at Göbekli Tepe bear carvings of animals long extinct or no longer native to the region, depicting fauna that would have existed during the Ice Age but vanished afterward. This suggests the builders either lived through the climate transition or preserved memory of it. The astronomical alignments encoded in the site's layout track stellar positions from the era of its construction, demonstrating knowledge of celestial mechanics and long-term sky observation. Most intriguing of all, the quality of stonework decreases over time at Göbekli Tepe. The oldest layers show the most sophisticated construction, the most elaborate carvings, the most precise engineering. As centuries pass, the quality declines. The pillars become smaller, the carvings cruder. This is the opposite of what we expect from human development. We expect improvement over time, growth of knowledge and capability. But at Göbekli Tepe, the pattern suggests decline, degradation, loss of knowledge and ability. Exactly what we would expect if the site was built by survivors of an earlier, more advanced civilization, who gradually lost the knowledge they inherited as generations passed and the old ways faded from memory. Move forward in time a few thousand years to the island of Malta in the Mediterranean Sea. Here stand the megalithic temples of Gargantia, Hajarkim, and Menidra. Massive stone complexes built from blocks weighing up to 20 tons, fitted together with remarkable precision. These temples date to approximately 3500 BC, making them older than the pyramids, older than Stonehenge, older than almost any other known megalithic construction. The temples are aligned to astronomical events: sunrise on the equinoxes, sunset on solstices. They incorporate sophisticated acoustic properties that modern researchers have only recently begun to understand. The underground chambers resonate at specific frequencies when sounds are produced within them, frequencies that match those known to affect human consciousness and induce trance states. Was this intentional? Did the builders understand the relationship between sound, space, and human neurology? If so, how? The traditional narrative claims these temples were built by simple farming communities that had only recently adopted agriculture. Yet the engineering sophistication, the astronomical knowledge, and the acoustic understanding embedded in these structures suggest capabilities far beyond what subsistence farmers should have possessed. Unless, of course, these farmers were descendants of people who remembered more, who carried within their cultural memory the fragments of greater knowledge from an earlier age. Cross the ocean to the Americas, to the mysterious ruins scattered throughout Peru and Bolivia. Here the pattern repeats, with variations that make it no less enigmatic. At Ollantaytambo, massive blocks of red granite weighing more than 50 tons each have been transported from a quarry on the opposite side of a river valley, lifted nearly 2,000 feet in elevation, and positioned with such precision that their surfaces align perfectly despite their enormous weight. The blocks show evidence of being shaped while still soft or plastic, with tool marks that suggest the stone was somehow manipulated in ways we cannot reproduce with modern technology. At nearby Sacsayhuaman, enormous walls snake across the hillside above Cuzco, constructed from limestone blocks weighing up to 200 tons, fitted together in intricate polygonal patterns where each stone interlocks with its neighbors through complex angles and curves. No mortar binds these blocks, yet they fit so precisely that a knife blade cannot slip between them. The walls have survived earthquakes that destroyed later Spanish colonial buildings, the massive stones absorbing seismic energy through their irregular interlocking shapes, an engineering technique that modern architects have only recently begun to appreciate and attempt to emulate. The Inca, who occupied these sites when the Spanish arrived in the 16th century, insisted they did not build these structures. They claimed to have found them already ancient, constructed by the gods, or by giants in an earlier age. Spanish chroniclers recorded these claims with bemusement, assuming the Inca were simply being modest or mythological. But what if the Inca were telling the simple truth? What if they really were the inheritors rather than the builders, maintaining and occupying structures created by predecessors whose capabilities exceeded their own? This pattern, later cultures occupying and venerating ruins they did not build, appears repeatedly across the ancient world. The Romans built atop foundations at Baalbek they could not explain. The Egyptians of later dynasties restored and repaired pyramids they claimed were ancient even in their time. The Maya built their temples over earlier structures that showed superior construction techniques. Again and again we find evidence of civilizations building on the ruins of what came before, attempting to match achievements they could not fully understand. At Tiwanaku, near Lake Titicaca in Bolivia, the pattern reaches perhaps its most extreme expression. This vast complex sits at nearly 13,000 feet above sea level, in an environment so harsh that modern humans struggle with altitude sickness and oxygen deprivation. Yet here stand the remains of an enormous city, complete with sophisticated irrigation systems, massive stone monuments, and architectural alignments to astronomical phenomena. The precision of the stonework matches or exceeds what we see in Egypt. Blocks are fitted with microscopic gaps. Surfaces are flat to tolerances measured in fractions of millimeters. Drill holes show evidence of technical capabilities that should not have existed in ancient South America. Most puzzling of all are the signs of what appears to be ancient technology. Some stones show marks suggesting they were cut with power tools, with parallel striations and curved cuts that cannot be explained by copper tools or stone abrasion. Other blocks appear to have been cast rather than carved, as if someone possessed the capability to create a form of primitive concrete from molten or softened stone. Strange metal clamps join some blocks together, made from an unusual alloy that shows signs of sophisticated metallurgy. Traditional dating places Tiwanaku's main construction period at around 500 to 900 AD. But this dating relies on organic materials found in association with the stones, not the stones themselves. And local traditions speak of the city as already being ancient and ruined long before the people who became the Tiwanaku culture arrived in the region. Geological evidence suggests the sophisticated port facilities at nearby Pumapunku were built when the water level of Lake Titicaca was higher, possibly thousands of years higher, indicating construction during a much earlier, wetter climatic period that ended long before the conventional dates. If Tiwanaku and Pumapunku are far older than conventional archaeology suggests, if they date to the end of the last ice age or before, then we must confront the disturbing possibility that there was an advanced Andean civilization 12 or 13,000 years ago, contemporary with the mysterious builders who created Göbekli Tepe, who weathered the Sphinx, who may have constructed the original foundations beneath the Giza pyramids. A global civilization, or at least a network of related cultures spread across continents, all achieving similar levels of sophistication, all demonstrating knowledge and capabilities that should not have existed in that era, and all destroyed within what seems to be a narrow window of time around 11,800 years ago, when something catastrophic struck the Earth and reset human civilization to nearly zero. The geological evidence for this catastrophe grows stronger each year. Deep ice cores from Greenland show sudden, dramatic climate shifts at the end of the Younger Dryas period. Temperatures that had been steadily cooling suddenly spiked upward by as much as 15 degrees Celsius in a matter of decades, a rate of change far faster than anything in the normal climate record. Such rapid warming would have caused the massive ice sheets covering North America and Northern Europe to melt with terrifying speed, releasing unimaginable volumes of water into the oceans. Sea levels rose by more than 300 feet as the Ice Age ended. But this rise did not occur gradually over millennia. Evidence suggests it happened in pulses, sudden catastrophic surges when ice dams failed and enormous glacial lakes burst free, sending walls of water hundreds of feet high racing across the landscape. The channeled scablands of Washington state bear the scars of these megafloods, where Ice Age floods stripped away hundreds of feet of rock and soil, carving massive channels through the bedrock in a matter of days or weeks. If such floods occurred in North America, they would have occurred elsewhere too. Any coastal civilizations, any cities built along the shores when sea levels were lower, would have been obliterated. The survivors would have fled inland, carrying what they could, remembering what they witnessed, preserving in story and song the memory of the world they lost. This is the flood of mythology, not a simple rainstorm lasting 40 days, but a global cataclysm lasting decades or centuries, as the Ice Age ended and the world's geography transformed. Coastlines drowned beneath hundreds of feet of water. River valleys flooded and became seas. Inland lakes burst their boundaries and carved new channels to the ocean. Entire landscapes vanished beneath the waves, taking with them everything that had been built upon them. The Mediterranean Sea was once a valley. The Black Sea was a freshwater lake until the Mediterranean broke through the Bosporus in a catastrophic flood that raised water levels hundreds of feet in a matter of months.
The Persian Gulf was dry land, a fertile plain crossed by rivers, until the rising ocean poured in and drowned it. The English Channel did not exist. Britain was connected to continental Europe by dry land until the Atlantic broke through and created the strait we know today. Everywhere the pattern repeats. Drowned coastlines, submerged cities, lost landscapes that exist now only in myths and memories. And because we live in an era when sea levels have been relatively stable for thousands of years, we forget how dramatically different the world looked before the flood. We forget that the most desirable places to build cities are always the coastlines, where rivers meet oceans, where harbors provide access to trade and fishing provides abundant food. We forget that all those prime locations now lie beneath hundreds of feet of seawater, covered by sediment, impossible to excavate, their ruins hidden from our searching eyes. How many cities lie drowned beneath the waves? How many centers of learning? How many libraries? How many temples and palaces and monuments to human achievement rest on the ocean floor, slowly dissolving as the centuries pass? We will never know, because the technology required to search the continental shelves thoroughly does not yet exist. We have mapped the surface of Mars in greater detail than we have mapped our own ocean floors. But occasionally, tantalizing hints emerge. Ruins discovered off the coast of India near Dwarka, submerged structures that may date to 7,000 years ago or earlier. Underwater formations near Yonaguni in Japan that bear striking resemblance to worked stone, though their artificial nature remains hotly disputed. Anomalies detected by sonar off Cuba, showing what appear to be geometric structures at depths that should not contain human constructions. None of these findings have been definitively proven to be artificial, yet neither have they been definitively proven to be natural. They exist in limbo, ignored by mainstream archaeology because they do not fit the established timeline, yet tantalizing to those willing to consider that human history might be older and stranger than we have been taught. The monuments that survived did so because they were massive enough to withstand the catastrophe, because they were positioned far enough from the coasts to escape the worst flooding, or because they were built on high ground where the waters could not reach. These monuments now stand as the only remaining evidence of what was lost, as fragments of a greater whole that has vanished. And perhaps, encoded within these monuments, within their proportions and alignments and mathematical relationships, lies a message from the builders. A message that says, "We were here. We achieved greatness. We understood things you have forgotten. Do not lose this knowledge again. Remember us. Remember what we built. Remember that it is possible for everything to be swept away, and that wisdom preserved in stone may be humanity's only inheritance when all else fails. The Great Pyramid stands as such a message. Its mathematical precision, its astronomical alignments, its geological position, all combine to create a monument that contains within its structure vast amounts of encoded information. It is not simply a tomb. It is an encyclopedia in stone, a time capsule designed to survive millennia, a beacon calling across the centuries to those who have eyes to see and minds willing to understand. The same may be true of other megalithic monuments around the world. Stonehenge with its precise solar and lunar alignments, the massive stones of Baalbek that demonstrate capabilities we struggle to match even with modern equipment, the enigmatic ruins scattered across the Pacific Islands, where massive stone platforms and statues hint at a maritime culture of unexpected sophistication.
The underwater structures off the coast of multiple continents, waiting to be properly explored and documented. All these may be fragments of the same story, pieces of a puzzle that depicts a human civilization far older than history records, far more capable than we have believed possible, far more extensive in its reach and influence than conventional scholarship will admit. And if this civilization existed, if it achieved such heights, if it possessed such knowledge and such capabilities, then we must ask the most important question of all. What destroyed it? What force was powerful enough to obliterate a global culture, to sink their cities beneath the waves, to scatter the survivors so thoroughly that almost nothing remained but myths and monuments? The language of stars. There is a mathematics that transcends time, a language written not in words but in ratios and proportions, angles and alignments. It is a language that speaks across millennia, indifferent to the rise and fall of empires, immune to the degradation that destroys parchment and papyrus. It is the language in which the ancient monuments speak to us, if only we learn to listen. Stand once more before the Great Pyramid and consider what it truly represents as a mathematical object. The structure embodies the number pi, that mysterious constant that describes the relationship between a circle's circumference and its diameter, not once, but repeatedly throughout its design. The perimeter of the pyramid's base divided by twice its height yields pi to several decimal places. This cannot be accidental repetition. This is intentional encoding of mathematical knowledge in permanent form. But pi is only the beginning. The pyramid also encodes phi, the golden ratio, that number approximately equal to 1.618 that appears throughout nature, in the spiral of seashells, the branching of trees, the proportions of the human body.
The ratio of the pyramid's slant height to half its base length equals phi with remarkable precision. Again, this appears not as isolated coincidence, but as systematic incorporation of fundamental mathematical constants into the structure's design. The pyramid's dimensions encode the proportions of the Earth itself. If you take the perimeter of the pyramid's base and multiply it by 43,200, you get the Earth's equatorial circumference. If you take the pyramid's height and multiply it by that same factor, you get the polar radius of the Earth from center to pole. The pyramid is a scale model of the Northern Hemisphere, accurate to a degree that should be impossible for people who supposedly lack the means to measure the Earth's dimensions. How did they know? How could Bronze Age Egyptians, working with crude surveying tools and without modern instruments, determine the Earth's size with such precision? The conventional answer is that they could not have, that these mathematical relationships must be coincidental. But how many coincidences must accumulate before we admit the possibility of intentional design based on actual knowledge? The answer becomes clearer when we consider that the knowledge may not have originated in Bronze Age Egypt. If the pyramids' foundations are older than conventional dating suggests, if they were laid by survivors of the pre-flood civilization who possessed inherited astronomical and geographical knowledge, then the mathematical encoding becomes explicable. They knew the Earth's dimensions because their predecessors had measured them. They incorporated this knowledge into the pyramid's design because they wanted to preserve it, to create a monument that would teach future generations the size and shape of the world, even if all other records were lost. The same mathematical sophistication appears in other ancient structures.
Stonehenge, that circle of massive stones on the Salisbury Plain in England, encodes astronomical knowledge of extraordinary precision. The monument tracks not only the obvious solar alignments, sunrise on the summer solstice, sunset on the winter solstice, but also the more subtle cycles of the moon. The arrangement of stones allows prediction of lunar eclipses through a cycle called the Saros, which takes more than 18 years to complete. To discover this cycle requires systematic observation spanning decades or even centuries. To encode it in stone demonstrates commitment to preserving astronomical knowledge for posterity. But Stonehenge also embodies mathematical relationships that suggest sophisticated geometric understanding. The positions of the stones can be used to generate Pythagorean triangles, right triangles whose sides follow integer ratios. The monument incorporates the same golden ratio found in the Great Pyramid. The distances between certain stones relate to each other through ratios that involve square roots of prime numbers. Mathematical relationships that should not have been known to Neolithic peoples supposedly working without written language or formal mathematical training. Unless, of course, they possessed inherited knowledge. Unless they were building on foundations laid by predecessors who understood mathematics more deeply than conventional history suggests. Unless Stonehenge, like the pyramids, represents an attempt to preserve in stone the wisdom of an earlier age. Cross the Atlantic to the Americas, and the pattern repeats with variations. At Chichen Itza in the Yucatan, the Great Pyramid of Kukulkan demonstrates astronomical knowledge encoded in architectural form. The structure has 91 steps on each of its 4 sides, totaling 364 steps plus the temple platform on top. 365 total, matching the days in a solar year. During the spring and autumn equinoxes, the setting sun creates a shadow pattern on the pyramid's northern staircase that appears as a serpent descending from the temple, a precise alignment that requires sophisticated understanding of solar mechanics and geometric design. But the pyramid encodes more than just the solar year. The Maya understood the precession of the equinoxes, that slow wobble in Earth's axis that takes nearly 26,000 years to complete one full cycle. They tracked the movement of Venus with accuracy that rivals modern astronomy. They calculated the lunar month to within seconds of the value determined by modern instruments. Their calendar systems integrated multiple cycles, solar, lunar, and Venus cycles, with mathematical precision that demonstrates deep understanding of celestial mechanics. How did they acquire this knowledge? The conventional answer points to centuries of patient observation by Maya astronomers. But this explanation becomes less satisfying when we consider that the astronomical knowledge appears fully formed in the earliest Maya texts, rather than showing gradual development.
The earliest surviving Maya inscriptions already demonstrate sophisticated calendrical calculations. The long count calendar, which tracks days from a 0 point in the distant past, appears complete rather than showing signs of evolution from simpler systems. This suggests inheritance rather than invention. The Maya, like the Egyptians and the builders of Stonehenge, may have been preserving and maintaining knowledge passed down from an earlier source. Their astronomical sophistication may represent recovery and continuation of observations begun by predecessors who lived through the catastrophe and understood the importance of tracking celestial cycles. The mathematics of these ancient monuments speaks a universal language because mathematics itself is universal. Pi exists independent of human culture.
The golden ratio appears in nature regardless of whether humans recognize it. The relationships between celestial cycles remain constant across millennia. By encoding these mathematical relationships in stone, the ancient builders created monuments that could communicate across cultural and linguistic boundaries, that could teach essential principles to anyone capable of measurement and calculation, regardless of what language they spoke or what cultural traditions they followed. This universality may have been intentional. If the builders anticipated that their civilization might not survive, that knowledge might be lost, that future generations might not even speak the same languages, then encoding information in mathematical form becomes the logical solution. Mathematics requires no translation. A right angle remains 90 degrees in any language. The ratio of a circle's circumference to its diameter remains pi, whether calculated in Egypt or England or China. Astronomical alignments function regardless of cultural context. The monuments become textbooks in stone, teaching mathematics and astronomy to anyone willing to measure and calculate. The lessons remain available across thousands of years, immune to the decay that destroys papyrus and paper, resistant to the cultural changes that render ancient languages incomprehensible. The knowledge persists because it is written in the most permanent form possible, not in symbols that must be decoded, but in proportions that can be directly measured. But the mathematical encoding goes deeper still, into realms that modern science is only beginning to appreciate. Recent research has discovered that many ancient structures incorporate what are called sacred geometries, geometric relationships that appear to bridge mathematics and consciousness, form and awareness. These geometries appear across ancient cultures in patterns too consistent to be coincidental. The flower of life, a geometric pattern formed by overlapping circles, appears carved into the walls of the Osirian in Egypt, stamped into metal artifacts in China, woven into Irish designs, carved into wood in Japan. This pattern, seemingly simple, contains within it the seeds of complex geometric relationships. From the flower of life can be derived the Platonic solids, the 5 three-dimensional shapes whose faces are all identical regular polygons. These solids, tetrahedron, cube, octahedron, dodecahedron, and icosahedron, appear throughout nature at scales ranging from viruses to crystals to cosmic structures. The ancient philosophers recognized something profound in these shapes. Plato associated them with the fundamental elements of reality. The tetrahedron represented fire, the cube, earth, the octahedron, air, the icosahedron, water, and the dodecahedron, the cosmos itself.
Modern physics has discovered that these shapes do indeed appear at fundamental levels of reality, in the geometric arrangements of atoms, in the structure of molecules, in the organization of space at quantum scales. Did the ancients somehow understand these deep relationships between geometry and physical reality? Did they recognize that certain proportions and shapes resonate with fundamental structures of the universe? The ubiquity of sacred geometry across ancient cultures suggests they did, though how they acquired this understanding remains mysterious. Consider the vesica piscis, the almond-shaped figure formed by the intersection of two circles whose centers each lie on the other's circumference. This simple geometric form generates ratios related to the square root of 3, a number that appears throughout physics and engineering. The vesica piscis appears in ancient architecture from Egypt to Greece to India, always in contexts suggesting sacred or ritual significance. It forms the basis for the pointed arch that would later enable the construction of Gothic cathedrals. It appears in early Christian symbolism, in Buddhist mandalas, in Islamic tile work. The same shape, independently arising across cultures separated by continents and millennia. Or the spiral, that shape which appears in the chambered nautilus, in spiral galaxies, in the curve of a hurricane, in the arrangement of seeds in a sunflower. The ancient Irish carved spirals into their megalithic monuments thousands of years before the Greeks formalized the mathematics of the logarithmic spiral. The spiral appears in Maori tattoos, in Celtic knots, in the serpent symbols of Mesoamerica, in the petroglyphs of the American Southwest. It represents growth, expansion, the unfolding of potential into manifestation, concepts that bridge mathematics and metaphysics, geometry and meaning. The ancients seem to have recognized that certain geometric forms carry significance beyond their mathematical properties, that they resonate with something deeper in human consciousness or in the structure of reality itself. Modern research into somatics, the study of visible sound wave patterns, has shown that when sand or liquid is vibrated at specific frequencies, it spontaneously organizes into geometric patterns that closely resemble sacred geometries. Sound, frequency, vibration creates form and order from chaos. The ancients may have understood this relationship, may have recognized that the universe itself is structured by principles that can be expressed geometrically. This knowledge appears encoded in the acoustic properties of ancient structures. The king's chamber in the Great Pyramid resonates at approximately 116 Hz, a frequency that modern research has shown can induce altered states of consciousness. The underground chambers at Malta resonate at around 110 Hz, in a range known to affect human brain function. The megalithic chambers in Ireland, particularly at Newgrange, demonstrate acoustic properties suggesting they were designed to resonate at specific frequencies. Were these chambers designed as consciousness-altering spaces? Were the ancients using sound and geometry to induce specific mental states that facilitated learning, healing, or spiritual experience? The evidence suggests they possessed sophisticated understanding of how sound behaves in enclosed spaces, how particular frequencies affect human neurology, and how architecture can be designed to create specific acoustic environments. This understanding may have been part of the lost knowledge from before the flood. If the pre-catastrophe civilization possessed advanced understanding of acoustics, this knowledge would have been among the most valuable to preserve. Unlike technologies that require complex infrastructure, acoustic principles can be demonstrated with simple materials. A resonant chamber can be built from stone using knowledge of geometry and proportion. The technology is low-tech, but the knowledge behind it is highly sophisticated. The same may be true of other forms of encoded knowledge. The astronomical alignments built into ancient monuments represent sophisticated understanding of celestial mechanics, but the monuments themselves require only stone and labor to construct. The mathematical relationships encoded in architectural proportions demonstrate advanced mathematical knowledge, but can be preserved through simple measurement and geometry. The sacred geometric patterns that appear in ancient art and architecture carry complex information, but can be reproduced with compass and straightedge. This is precisely the kind of knowledge that would be most valuable to preserve in the aftermath of catastrophe. Technologies that depend on electricity, advanced metallurgy, or complex chemistry would be impossible to maintain when civilization collapses. But knowledge encoded in stone, expressed through geometry, preserved in astronomical alignments, this knowledge can survive and be transmitted even when more sophisticated means of record-keeping have been lost. The monuments function as time capsules, but time capsules of a very particular kind. They do not simply preserve information in fixed form like a buried box of documents. They are interactive educational tools, designed to teach anyone willing to measure and observe and calculate. The lessons are there for those who seek them. The knowledge waits patiently in stone for minds capable of recognizing what is being communicated. And the communication extends beyond purely practical information. The monuments seem designed to transmit something more: a sense of awe, a recognition of cosmic scale, an understanding that humanity exists within a universe governed by mathematical principles and celestial mechanics. Standing within the grand gallery of the Great Pyramid, or beneath the massive stones of Stonehenge, or in the resonant chamber at Newgrange, one cannot help but feel small and yet connected to something vast. The monuments inspire humility and wonder in equal measure. Perhaps this too was intentional. Perhaps the builders wanted future generations not merely to know, but to feel. Not merely to calculate, but to understand that we are part of something larger than ourselves. The monuments speak not just to the intellect, but to the emotions, creating experiences that lodge in memory and imagination, that inspire questions and seeking, that refuse to be forgotten or dismissed. Consider the experience of standing at Stonehenge on the summer solstice, watching the sun rise precisely over the heelstone, illuminating the center of the circle with golden light. The alignment is exact, predicted by geometry, explained by astronomy. Yet the experience transcends mere calculation.
There is magic in that moment. Not supernatural magic, but the magic of deep time and human ingenuity. The recognition that people who lived thousands of years ago created this alignment, understood these principles, wanted their distant descendants to witness this moment and remember that humans can achieve extraordinary things. Or consider standing inside the king's chamber in the Great Pyramid, surrounded by red granite walls, feeling the resonance when sound is produced in that space. The chamber hums at its fundamental frequency, the sound seeming to come from the stones themselves, vibrating in your chest and skull, altering perception in subtle ways that science is only beginning to understand. This is experiential knowledge, impossible to fully convey in words or numbers. requiring direct experience to comprehend. The chamber was designed to create this experience, to teach through sensation what cannot be adequately taught through description. The ancient builders understood something that modern education has largely forgotten: that knowledge is not merely intellectual but embodied, not just abstract but experiential, not only rational but also intuitive and emotional. They created monuments that teach on multiple levels simultaneously, that communicate to different aspects of human consciousness, that integrate mathematics and meaning, geometry and spirituality, astronomy and awe. This integrated approach to knowledge may represent one of the most important legacies of the pre-flood civilization. In our modern world, we have fragmented knowledge into specialized disciplines: physics, separate from philosophy; mathematics, divorced from meaning; science, isolated from spirituality. We have gained precision and rigor through this specialization, but we have lost the synthetic understanding that recognizes connections between different domains of knowledge. The ancients seem not to have made these divisions. For them, astronomy was both science and religion. Mathematics was both practical tool and sacred wisdom. Architecture served functional purposes while embodying cosmic principles. Knowledge formed an integrated whole rather than fragmented specialties. This holistic understanding may have enabled insights that our more fragmented approach makes difficult to achieve. Modern science is beginning to rediscover some of these connections. Quantum physics has revealed that consciousness and observation affect physical reality in ways that blur the boundary between subjective and objective. Neuroscience has shown that meditation and contemplative practices produce measurable changes in brain structure and function. Psychology has demonstrated that meaning and purpose affect physical health and mental well-being. The rigid boundaries between disciplines are softening as we recognize that reality is more interconnected than our specialized knowledge domains suggest. Perhaps we are slowly recovering the integrated understanding that the ancients possessed. Perhaps the monuments they left behind are helping to guide this recovery, teaching us not just specific facts about mathematics and astronomy, but broader lessons about the nature of knowledge itself, about the importance of preserving wisdom across generations, about the value of creating works that endure beyond individual lifespans. The mathematical language written in stone speaks across 12,000 years, carrying messages from a lost world to ours. Some of these messages we are learning to read: the astronomical alignments, the geometric proportions, the mathematical constants. Other messages remain cryptic, encoded in ways we do not yet understand, waiting for future advances in knowledge to unlock their meanings. But perhaps the most important message is the simplest: that knowledge can be lost, that civilizations can fall, that wisdom accumulated across centuries can vanish in a single catastrophic event, and that therefore those who possess knowledge have a responsibility to preserve it, to encode it in forms that will survive catastrophe, to pass it forward to generations yet unborn, who may need to recover what has been lost. The ancient builders fulfilled this responsibility as best they could. They carved their knowledge into stone, aligned their monuments to the stars, encoded mathematical relationships in architectural proportions,
created spaces designed to teach through direct experience. They built not for themselves but for us, for the distant descendants they would never meet, hoping that we would find their messages and learn from them. Now the question is whether we will fulfill our own responsibility, whether we will preserve the knowledge we have gained for those who come after us, whether we will create monuments, physical or digital or cultural, that will survive the catastrophes that may come, whether we will look beyond our immediate needs and short-term thinking to consider what legacy we leave for the far future. The ancient monuments remind us that time is long and human civilizations are fragile. They stand as evidence that greatness can be achieved and then lost. They warn us that the sky can fall, that the waters can rise, that everything we build can be swept away. But they also demonstrate that knowledge can survive, that wisdom can be preserved, that the efforts we make to teach and preserve and pass forward can echo across millennia. We are the inheritors of a legacy far older than we once imagined. The monuments speak to us across the abyss of time, carrying messages from the lost world before the flood. The question now is what we will do with this inheritance.
Will we listen to what the monuments are teaching? Will we take seriously the warnings they carry about the fragility of civilization and the importance of preservation? Will we add our own voice to the conversation across time, creating our own monuments and messages for the generations that will come after we are gone? The mathematics of the stars is patient. The language written in stone endures. The knowledge waits for those ready to receive it. And the cycle continues, as it has continued for thousands of years, as it may continue for thousands more. The rising and falling of civilizations, the losing and recovering of knowledge, the endless human struggle to understand, to remember, and to preserve what matters most. The keepers of memory. In the darkness after the catastrophe, when the cities had drowned and the libraries had burned, and the great monument stood alone amid the ruins, there were those who remembered. They were not many, these survivors who carried within their minds the fragments of what had been lost. But they were enough. They became the keepers of memory, the bearers of knowledge, the teachers who would preserve across the terrible centuries of recovery the seeds from which civilization might grow again. Who were they? We know them only through the shadows they cast in later mythology, through the stories told about them by cultures that arose long after they lived. The Egyptians called them the Shemsu Hor, the followers of Horus, and said they brought the wisdom of the gods to the Nile Valley. The Sumerians knew them as the Apkallu, the 7 sages who emerged from the sea to teach the arts of civilization. The Maya spoke of Kukulkan and Quetzalcoatl, the feathered serpents who came from across the waters bringing knowledge and wisdom. In India, they were the Rishis, the enlightened ones who preserved the Vedas across the cycles of destruction and creation. Different names in different languages, but always the same essential story. Wise teachers who came from elsewhere, who possessed knowledge of astronomy and architecture and agriculture, who taught the survivors how to rebuild, how to measure the stars, how to construct monuments that would endure. They were not gods, though later ages would deify them. They were not supernatural beings, though their knowledge seemed magical to people who had lost almost everything. They were survivors of the lost world,
refugees from the catastrophe, determined that what their civilization had learned across millennia would not die with them. Imagine their burden. They had witnessed the end of their world. They had watched the sky split open and rain fire upon the earth. They had seen the oceans rise and the cities drown, and the people they loved consumed by water and flame and chaos. They had survived through some combination of fortune and foresight, perhaps fleeing to high ground before the worst of the flooding, perhaps possessing boats or ships that allowed them to ride out the catastrophe on the open sea. But survival was only the beginning of their struggle. They emerged into a transformed world. The coastlines where the great cities had stood were drowned beneath hundreds of feet of water. The climate had changed, plunging back into the cold of the Ice Age for more than 1,000 years. The megafauna that had provided food were dying or already dead. The crops that had sustained civilization no longer grew in the frigid temperatures. The networks of trade and communication that had connected distant regions were severed. They were isolated, scattered, struggling simply to stay alive from one season to the next. Yet despite everything, they held on to their knowledge. They remembered the mathematics and the astronomy. They remembered the techniques of architecture and engineering. They remembered the stories and the wisdom accumulated by their ancestors across thousands of years. And they understood that this knowledge was precious, that it might mean the difference between survival and extinction for the human species, that it must be preserved and passed forward, no matter the cost. So they taught. They found survivors, small bands of hunter-gatherers trying to endure through the catastrophe, and they taught them. They taught them agriculture, how to select and plant seeds, how to irrigate and fertilize, how to store surplus for lean times. They taught them architecture, how to construct permanent dwellings, how to work stone, how to build structures aligned to the movements of sun and stars. They taught them astronomy, how to track the seasons by celestial markers, how to predict the flooding of rivers, how to navigate by the stars. They taught them mathematics, the principles of counting and measuring and calculating that would allow future generations to design and build and plan. But they faced enormous challenges. Their students were few and often struggled to understand concepts that had taken their own civilizations centuries to develop. Writing systems had been lost in the catastrophe, forcing knowledge to be transmitted orally through memory and repetition. The technologies that had made life comfortable in the pre-flood world could not be recreated without the infrastructure and resources that no longer existed. They had to simplify, to focus on what was most essential, to accept that much of what they knew would die with them because there was simply no way to preserve it all. So they made choices about what to preserve and how to preserve it. They encoded knowledge in monuments, building massive stone structures that would survive when everything else crumbled. They embedded information in myths and stories, wrapping practical knowledge in narrative form that would be memorable and could be passed down orally across generations. They established priesthoods and mystery schools, creating institutions dedicated to preserving specialized knowledge through intensive training and initiation. They created calendars and astronomical observatories, ensuring that the crucial knowledge of celestial cycles would not be forgotten. The monuments they built or instructed others to build served multiple purposes simultaneously. They were temples and tombs and observatories, yes, but they were also textbooks and archives and warnings. The Great Pyramid,
if its foundations were laid by these knowledge keepers, served as a repository of mathematical and astronomical information, encoded in its proportions and alignments. Göbekli Tepe functioned as an astronomical observatory and teaching center, where survivors could learn to track the movements of celestial bodies. The stone circles scattered across Europe and the megalithic structures throughout the Americas and Asia all served as permanent records of knowledge that could no longer be written in books that would decay and be lost. But there was another purpose to these monuments, a psychological and spiritual dimension that went beyond mere information preservation. The keepers of memory understood that for knowledge to be valued, it must be embedded in meaning. For techniques to be maintained across generations, they must be connected to purpose and identity. For civilization to rebuild, people needed not just practical skills, but also a sense of connection to something greater than themselves, a reason to invest effort in projects that would not benefit them directly, but would serve their distant descendants. So the monuments became sacred. The astronomical knowledge became ritual. The mathematical principles became mystery. The keepers of memory established traditions and ceremonies and initiations that gave meaning to the knowledge they were preserving, that created continuity between past and future, that bound communities together in shared purpose.
They understood that humans need stories and symbols and sacred spaces, that we are not merely rational calculators, but meaning-seeking beings who require purpose and connection. This is why astronomy became astrology, why mathematics became numerology, why engineering became sacred architecture. Not because the keepers of memory were primitive or superstitious, but because they understood that knowledge wrapped in meaning and sanctity would be preserved more carefully than purely utilitarian information. A farmer might forget the optimal planting date calculated from solar position, but he would remember the sacred festival that marked the time to plant. A builder might lose track of mathematical ratios, but he would maintain the proportions of the temple built according to divine specifications. Knowledge, disguised as religion, stood a better chance of surviving across the dark centuries than knowledge presented as mere practical technique. The mystery schools served this purpose particularly well. In Egypt, in Greece, in India, in Mesoamerica, there arose institutions that guarded specialized knowledge, revealing it only to initiates who had proven themselves worthy through study and dedication. The Eleusinian mysteries in Greece, the temples of Isis in Egypt, the Vedic schools in India, the priestly colleges of the Maya, all served as repositories of preserved knowledge, maintaining through secrecy and selectivity the information that might otherwise be lost or corrupted. Critics dismissed these mystery schools as exercises in elitism, as ways for priestly classes to maintain power by hoarding knowledge. And certainly some of that dynamic existed, but there was also a genuine preservation function. Knowledge that is too widely distributed without proper context and understanding tends to become degraded, simplified, misunderstood. Specialized knowledge requires specialized training to be properly maintained and applied. The mystery schools provided that training, ensuring that at least some people in each generation mastered the deeper principles that less trained practitioners might lose. Consider the example of geometry. In ancient Greece, the Pythagoreans treated geometric knowledge as sacred mystery, revealing the deeper principles only to initiated students who had demonstrated both intellectual capacity and ethical character. To outsiders, this seemed like arbitrary mystification of simple mathematics. But the Pythagoreans understood that geometry was not merely about measuring fields and constructing buildings. They recognized geometric relationships as fundamental patterns underlying reality itself, connections between form and number that bridged mathematics and metaphysics. This deeper understanding required extensive study and contemplation to grasp. It could not be casually taught to unprepared minds, without being reduced to mechanical techniques divorced from deeper meaning. The same pattern appears in other traditions. The Vedic knowledge in India was preserved by Brahmin priests who spent years memorizing vast texts with perfect accuracy, maintaining pronunciation and intonation across generations. This seemed excessive to outside observers. Why not simply write the texts down and let anyone read them? But the oral tradition ensured accuracy in ways that written texts, subject to copying errors and misinterpretation, could not match. The requirement of memorization also ensured that practitioners truly knew the material, had internalized it in ways that mere reading cannot achieve. The astronomical knowledge preserved by various priesthoods followed similar patterns. The Maya priests maintained incredibly complex calendrical systems, tracking multiple overlapping cycles with precision that required years of training to master. The Egyptian priests tracked the heliacal rising of Sirius, that moment when the star first becomes visible in the dawn sky, using it to predict the annual flooding of the Nile. The Babylonian priests recorded celestial observations for centuries, accumulating data that would eventually allow them to predict eclipses and planetary positions with remarkable accuracy. All of this required institutional continuity, spaces protected from the immediate pressures of survival, where specialists could dedicate themselves to observation and calculation and teaching. The mystery schools and priestly colleges provided that protection, creating islands of preserved knowledge in a world still struggling to recover from catastrophe. But the keepers of memory faced a cruel paradox. The very techniques that helped preserve knowledge, wrapping it in ritual, embedding it in myth, restricting access through initiation, also made it vulnerable to misunderstanding and loss of meaning. Over generations, the symbols became divorced from what they symbolized. The rituals continued, but their purpose was forgotten. The myths were repeated, but their informational content was no longer recognized. The mysteries remained mysterious, but because the knowledge they contained had been genuinely lost rather than merely hidden. This degradation of knowledge left traces throughout ancient cultures. The Egyptians of the New Kingdom maintained rituals and built temples according to proportions they no longer fully understood, following traditions established in the Old Kingdom, without grasping the mathematical and astronomical principles that had originally informed those traditions. The later Maya continued to use the sophisticated calendars developed by their ancestors, without retaining the full astronomical knowledge that had enabled the calendar's creation. The builders of Stonehenge in its later phases added smaller, cruder stones to a monument whose original design they could no longer match or fully comprehend. We see this pattern of declining knowledge encoded in the monuments themselves. At Göbekli Tepe, the oldest layers show the finest work, and quality declines over time until eventually the site is abandoned and deliberately buried. At Egyptian pyramids, the earliest examples demonstrate the greatest precision, with later pyramids showing progressively inferior construction despite supposedly having more accumulated experience to draw upon.
At Andean megalithic sites, the massive, precisely fitted stones appear in the oldest layers, with later additions using smaller rocks and cruder techniques. This is the signature of inherited knowledge being gradually lost. The first generations of keepers, those who had lived through the catastrophe or learned directly from those who had, possessed full understanding of the principles they were applying. They could achieve the highest quality because they truly understood what they were doing. But each subsequent generation lost something. The techniques were passed down, but the deep principles behind them were imperfectly transmitted. The rituals continued, but the reasons for them faded. The traditions persisted, but the knowledge they contained degraded like a message passed through too many iterations of a game of telephone. Still, the keepers of memory succeeded in their essential mission. They kept the flame of knowledge burning through the dark centuries after the catastrophe. They preserved enough astronomy that later civilizations could develop sophisticated calendars and navigate across oceans. They maintained enough mathematics that later cultures could build impressive structures and solve complex problems. They passed down enough agricultural knowledge that human populations could grow and cities could arise again. They ensured that the recovery of civilization would not have to start from absolute zero, that future generations would inherit at least some of what had been learned before the flood. And they preserved the memory of the catastrophe itself, encoding it in myths and monuments, ensuring that future generations would know that such things can happen, that the world can end, that everything can be swept away. This may have been their most important legacy. The understanding that civilization is fragile, that knowledge can be lost, that each generation has a responsibility to preserve what matters for those who come after. The flood myths found in every culture are not religious allegories or moral lessons, though they became those things over time. At their core, they are historical memories, preserved through oral tradition across hundreds of generations, maintained with remarkable consistency despite the lack of written records. The fact that these stories survived at all testifies to the determination of the keepers of memory, who understood that future humans needed to know what had happened, needed to remember that the cosmos can reach down and unmake human civilization in a single, terrible moment. Some researchers have suggested that the keepers of memory established what might be called a global civilization in the aftermath of the catastrophe. Not a unified empire, but a network of connected cultures sharing common knowledge and techniques, maintaining contact across vast distances, coordinating efforts to preserve and transmit what had been saved from the lost world. The evidence for this lies in the remarkable similarities found in megalithic constructions across continents separated by oceans, in the shared astronomical knowledge appearing in cultures with no obvious means of communication, in the parallel development of similar mythologies and symbols in regions supposedly isolated from one another. Consider the step pyramid form that appears in Egypt, in Mesopotamia, in Mesoamerica, in Southeast Asia. Different cultures, separated by thousands of miles and supposedly having no contact, all developed the same distinctive architectural form, a pyramid, built in successive levels, each level smaller than the one below, creating a stepped profile. The conventional explanation is convergent evolution, the idea that similar environmental pressures and human needs lead to similar solutions. But the step pyramid is not an obvious solution to any particular problem. It is neither the most efficient use of materials nor the easiest form to construct. Its appearance across distant cultures suggests shared knowledge rather than independent invention.
Or consider the myth of the feathered serpent that appears throughout Mesoamerica. Quetzalcoatl to the Aztecs, Kukulkan to the Maya, known by other names to other cultures but always essentially the same figure. A wise teacher who came from across the water, who brought knowledge of astronomy and agriculture and architecture, who taught the people and then departed with a promise to return. This same figure appears in the Sumerian god Enki, described as emerging from the sea to teach humanity. It appears in the Egyptian god Thoth, bringer of writing and wisdom. It appears in the Indian god Vishnu in his Matsya avatar, the fish who saved humanity from the flood and taught them how to rebuild. Different names, different details, but the same essential story told around the world. A teacher from elsewhere, associated with water and the sea, bringing knowledge after or before a great catastrophe. These are not independent inventions. These are cultural memories of actual teachers, the keepers of memory who traveled among the surviving populations after the flood, sharing what they knew, helping humanity recover and rebuild. The evidence suggests these knowledge keepers may have possessed maritime capabilities that allowed them to travel vast distances across oceans. There are curious anomalies in the distribution of plants and animals that hint at transoceanic contact in the deep past. Cotton species native to both the Americas and India somehow cross-pollinated despite thousands of miles of ocean separation. Sweet potatoes, native to South America, appear in Polynesia long before any documented contact. Cocaine and tobacco, plants native to the Americas, have been found in Egyptian mummies predating Columbus by thousands of years. These anomalies can be explained by ancient seafaring capabilities far more advanced than conventional history acknowledges. The ancient maps present perhaps the most intriguing evidence. The Piri Reis map, drawn in the 16th century but claiming to be based on much older sources, shows the coastline of Antarctica with remarkable accuracy, but depicts the continent without ice, showing geographical features that have been buried under mile-thick ice for thousands of years. The map should not exist. Antarctica was not officially discovered until the 19th century, and its ice-free coastline has not been visible for at least 6,000 years, possibly much longer. Yet someone mapped it, and that information was somehow preserved through the centuries and eventually copied onto Piri Reis's chart. Other ancient maps show similar anomalies. They depict coastlines and islands with surprising accuracy, despite being drawn in eras when such knowledge supposedly did not exist. They show longitude correctly calculated, a technique that European cartographers would not master until the 18th century, with the invention of accurate chronometers. They suggest the existence of a maritime culture capable of mapping the entire world, a culture that possessed navigational abilities and geographical knowledge far beyond what conventional history attributes to ancient peoples. Perhaps these were the knowledge keepers, the survivors of the pre-flood civilization, sailing the world's oceans in ships we can barely imagine, mapping coastlines and sharing knowledge, establishing contact with distant populations and teaching them what they needed to know. Perhaps they maintained this network for centuries or even millennia, slowly declining as the inherited knowledge faded and the ships that allowed them to cross oceans could no longer be maintained. Perhaps eventually they settled in various regions, intermarrying with local populations, establishing the priestly lineages and mystery schools that would continue their mission of preserving knowledge even as the means of global contact was lost. We may never know their true story. Too much time has passed. Too much has been forgotten. The flood took their cities and their libraries. The centuries took their ships and their tools. All that remains are the monuments they built or inspired, the myths they seeded into cultures around the world, the fragments of knowledge they managed to preserve despite everything. But those fragments are enough to hint at who they were and what they attempted. They were the bridge between the lost world and the civilization that emerged from its ruins. They were the teachers who ensured that humanity would not have to reinvent everything from scratch. They were the guardians who protected the flame of knowledge through the darkest centuries, keeping it alive until it could illuminate the world again. And they left us a legacy not just of knowledge but of responsibility. They showed us that it is possible to preserve wisdom across catastrophe, that determined individuals can make a difference even in the face of civilizational collapse, that what we choose to pass forward matters profoundly. They call to us across the millennia, these anonymous teachers, these keepers of memory, asking us to consider what we will preserve, what we will teach, what legacy we will leave for the generations that will come after we are gone. In an age of digital storage and instant communication, we might think the problem of preserving knowledge has been solved. But digital media is fragile, dependent on electricity and functioning infrastructure, and continuing technological compatibility. A solar flare, an electromagnetic pulse, a collapse of the power grid, any of these could wipe out digital archives more completely than the flood erased the libraries of the ancient world. The keepers of memory understood that truly durable knowledge must be encoded in more permanent forms, must be embedded in culture and practice and physical monuments, must be distributed widely enough that no single catastrophe can erase it entirely. Their methods may seem primitive to us, their stone monuments and oral traditions quaint in an age of cloud computing and artificial intelligence. But when the power fails and the servers go dark, and the intricate web of modern technology collapses under its own complexity or external shock, what will remain? What knowledge will survive for those who come after? What monuments are we building that will still stand when everything else has crumbled? These are the questions the keepers of memory pose to us. These are the challenges they faced and met with the tools available to them. Now we face similar challenges with different tools, and the question is whether we will prove as dedicated, as far-sighted, as determined to preserve what matters for the future, as those anonymous teachers who sailed the seas and built the monuments and told the stories that echo down to us across 12,000 years. The Watchers of the Threshold. There is a place between knowing and forgetting, where knowledge takes on different forms, where information becomes wisdom, where facts transform into understanding. The ancient peoples who came after the catastrophe lived in this liminal space, inheriting fragments of knowledge they could not fully comprehend, maintaining traditions whose original meanings had been lost, preserving techniques they could no longer perfectly replicate. They were watchers at the threshold between two ages, the lost world before the flood, and the emerging civilization that would eventually become our own. These threshold watchers left their own marks upon the ancient world, building upon foundations they did not create, adding their own layers to monuments erected by predecessors, attempting to bridge the gap between what had been and what might be again. They lived in the shadow of greatness they could not match, surrounded by evidence of capabilities they could not reproduce, yet determined to carry forward whatever they could salvage from the ruins of the past. The Egyptian civilization that arose along the Nile represents perhaps the clearest example of this threshold existence. The earliest dynasties appeared suddenly around 3000 BC, with writing, mathematics, sophisticated architecture, and astronomical knowledge seemingly fully formed, rather than showing gradual development. This has puzzled historians for generations. Where did this sudden sophistication come from? The conventional answer points to the gradual accumulation of knowledge during the pre-dynastic period. But the archaeological evidence for this accumulation remains frustratingly sparse. The alternative explanation, increasingly supported by various lines of evidence, is that early Egyptian civilization was a renaissance, a flowering based on inherited knowledge rather than newly discovered principles. The Egyptians themselves supported this interpretation. Their texts speak explicitly of the Zep Tepi, the first time, an age of gods and wisdom that preceded historical Egypt by thousands of years. They claimed their civilization was founded on knowledge given to them by the Shemsu Hor, the mysterious followers of Horus, who brought wisdom from an earlier age. The Egyptian priests told the Greek historian Herodotus that their civilization was already ancient when he visited in the 5th century BC, that their astronomical records stretched back more than 10,000 years. Herodotus and other Greek writers preserved these claims, though they were unsure what to make of them. Modern historians have generally dismissed such statements as priestly exaggeration, as attempts to claim spurious antiquity for religious authority. But what if the priests were telling the simple truth? What if Egyptian civilization really did rest on foundations far older than conventional chronology acknowledges? Consider the Sphinx again, that enigmatic monument whose water erosion suggests an age far greater than Orthodox Egyptology accepts. If the Sphinx predates the dynastic period by thousands of years, if it was already ancient when the pyramid builders of the 4th dynasty found it weathered and worn, then the early Egyptians were indeed working in the shadow of predecessor achievements. They would have seen this massive monument carved from living rock, demonstrating capabilities they could not fully match, and they would have dedicated themselves to honoring it, preserving it, building their own monuments nearby in an attempt to connect themselves to that earlier greatness. The Great Pyramid itself may tell a similar story. If its foundations and core structure are older than the 4th dynasty, if Khufu merely renovated and completed a structure begun by predecessors thousands of years earlier, then the remarkable mathematical and astronomical knowledge encoded in the pyramid's design need not have been possessed by Bronze Age Egyptians. They would have been maintainers and completers rather than originators, fulfilling a tradition established long before, working to finish what earlier builders had begun. This would explain the curious fact that the greatest pyramids appear at the beginning of the Pyramid Age, rather than as the culmination of gradual development. The Step Pyramid of Djoser, the Bent Pyramid, the Red Pyramid, and finally the Great Pyramid represent the highest achievement in pyramid construction. Later pyramids are smaller, cruder, showing inferior construction technique and less sophisticated design. This is the opposite of what we expect from technological development, where later examples should show improvement over earlier ones. But it makes perfect sense if the early pyramids were built using inherited knowledge that was gradually being lost. If the builders were working from templates and techniques they imperfectly understood, achieving their greatest works while the knowledge was freshest, and declining in capability as that knowledge degraded across generations. The same pattern appears in pyramid texts and funerary inscriptions. The earliest texts are often the most sophisticated, containing complex astronomical and cosmological references. Later versions of the same texts show signs of corruption and misunderstanding, as if scribes were copying passages whose meanings they no longer fully grasped. Words were misspelled, or replaced with similar-sounding but semantically different terms. Astronomical references were garbled. Mathematical relationships were simplified or lost. The knowledge was preserved, but imperfectly, degrading like a document passed through too many generations of copiers who treat it as sacred text to be reproduced exactly, even when they no longer understand what the words mean. Move forward in time to classical Greece, and we find another threshold culture, another civilization building on older foundations. The Greeks themselves acknowledged this. They spoke of learning from the Egyptians, of traveling to Egypt to study with the priests, of acquiring mathematical and astronomical knowledge from more ancient sources. Pythagoras supposedly spent years studying in Egypt and perhaps Babylon, learning the mathematical principles he would later teach in his own school. Plato studied in Egypt and brought back the story of Atlantis, claiming it was preserved in Egyptian records from 9,000 years before his time. Solon, the legendary Athenian lawgiver, visited Egypt and was told by the priests there that the Greeks were like children, that their civilization was young, and they had forgotten the wisdom of earlier ages. The Greeks took these lessons and built upon them, developing philosophy and mathematics and science to extraordinary heights. Yet even at their peak, they acknowledged they were working with inherited knowledge, that the foundations had been laid by others, that they were recovering and extending principles discovered in the distant past.
Plato's theory of forms, his idea that the material world is merely a shadow of perfect mathematical realities, may represent an attempt to explain how knowledge can exist independent of human discovery, how truths can be recovered rather than invented, how the wisdom of earlier ages might be reclaimed by later generations willing to pursue it. The Greek mystery schools, Eleusis, Delphi, the Pythagorean communities, all maintained initiatory traditions claiming to preserve ancient wisdom. They spoke of knowledge passed down from the time before the flood, of teachings preserved by survivors of earlier catastrophes, of techniques for achieving altered states of consciousness that allowed access to deeper levels of reality. Modern scholars tend to dismiss these claims as mystification and myth-making. But what if they contain kernels of historical truth? What if the mystery schools really were preserving fragments of pre-flood knowledge, maintaining techniques and practices that had been discovered by the lost civilization and transmitted through the long centuries of recovery? The sacred geometry found throughout Greek architecture and art suggests knowledge that goes beyond merely aesthetic preference. The golden ratio appears repeatedly in the Parthenon, in the proportions of Greek sculptures, in the layout of sacred sites. The Greeks understood that certain proportions create harmonious effects, that mathematical relationships can be embodied in physical form, that beauty and mathematics are intimately connected. Where did this understanding originate? Perhaps some of it was Greek discovery, but the ubiquity of similar geometric principles in far older structures suggests the Greeks were also inheriting and applying knowledge preserved from earlier times. Cross the Mediterranean to the ancient Near East, and the pattern continues. The Sumerian civilization appeared suddenly in Mesopotamia around 3000 BC, with sophisticated writing, advanced mathematics, astronomical knowledge, and architectural capabilities that seem to arrive fully formed rather than showing gradual development.
The Sumerians themselves claimed their civilization was taught to them by the Apkallu, the 7 sages who emerged from the sea before the flood to bring the arts of civilization to humanity. Like the Egyptian claims about the Shemsu Hor, modern historians have treated this as mythology. But what if it preserves actual cultural memory of teachers who came from elsewhere, bearing inherited knowledge? The Sumerian King List, that ancient text cataloging the rulers of Sumerian cities, speaks of kings who ruled before the flood, some for impossibly long periods, suggesting either symbolic rather than literal time measurements or textual corruption. But the fact that the King List explicitly divides history into pre-flood and post-flood periods suggests the Sumerians maintained clear cultural memory of a catastrophic divide, a moment when one age ended and another began. They knew that their civilization arose in the aftermath of something terrible, that they were rebuilding rather than building for the first time. The astronomical knowledge possessed by the Babylonian successors to the Sumerians demonstrates continuity with earlier traditions. The Babylonian priests maintained observational records spanning centuries, accumulated data about planetary positions and eclipse cycles, developed mathematical models for predicting celestial events. This knowledge did not arise overnight. It required generations of systematic observation, careful record-keeping, and mathematical sophistication. Where did the tradition begin? How far back did the astronomical observations reach? The Babylonian records that survive are copies of earlier texts, which were themselves copies of still earlier sources. The ultimate origin of this astronomical tradition may stretch back to before the flood, to observers who began the work of tracking celestial cycles in an age we can barely imagine. The biblical tradition, emerging from this same ancient Near Eastern context, also preserves memory of the threshold between ages. The story of Noah's Ark is the most obvious example, but there are others. The Tower of Babel story speaks of a time when all humanity spoke one language and attempted to build a structure reaching to heaven, before God scattered them and confused their speech. This might preserve memory of a time when human civilization was more unified, when shared knowledge allowed ambitious construction projects, before catastrophe scattered populations and broke linguistic and cultural continuity. The Genesis account of the antediluvian patriarchs, those figures who supposedly lived for hundreds of years before the flood, may represent a garbled memory of pre-flood civilizations, with the extraordinary lifespans indicating not individual longevity, but dynastic periods or cultural epochs. The names themselves: Enoch, who walked with God and was taken up to heaven; Methuselah, who lived longer than any other; Noah, who preserved life through the catastrophe, may be symbolic representations of knowledge transmission, of wisdom preserved through catastrophic transition, of the threshold watchers who maintained continuity between ages. Travel to India and the Vedic tradition presents perhaps the most explicit preservation of pre-catastrophe memory. The Vedas speak openly of previous ages, of cycles of creation and destruction, of civilizations that rose and fell before the current age began. The texts describe vimanas, flying machines used in ancient wars, They speak of powerful weapons whose effects sound remarkably like nuclear explosions. They preserve sophisticated astronomical knowledge, including awareness of the precession of the equinoxes, understanding of celestial mechanics, and mathematical concepts like zero and infinity that would not be discovered in the West for thousands of years. The Vedic texts were preserved through oral tradition with extraordinary fidelity across millennia. The Brahmin priests memorized vast quantities of verse with perfect accuracy, maintaining pronunciation and intonation across generations, creating a living archive more reliable than written texts, subject to copying errors. This dedication to perfect preservation suggests the culture understood they were maintaining something precious. Knowledge from an earlier time that must not be allowed to degrade or disappear. They were threshold watchers par excellence, guardians of inherited wisdom, determined that what had survived the catastrophe would survive into the future. The ruins at Mohenjo-Daro and Harappa in the Indus Valley reveal an ancient civilization contemporary with early Egypt and Sumer, possessing sophisticated urban planning, standardized measurements, and engineering capabilities that demonstrate advanced knowledge. Some of the artifacts found at these sites suggest cultural continuity with traditions described in the Vedas. The cities were abandoned suddenly, perhaps due to climate change or tectonic catastrophe. But the knowledge they possessed may have been carried forward by survivors, eventually contributing to the classical Indian civilization that would preserve it in the Vedic texts. Across the Pacific, the threshold watchers left different but equally intriguing traces. The massive stone platforms of Polynesia, the mysterious Moai statues of Easter Island, the elaborate stone cities of the Andes all suggest knowledge that arrived from elsewhere rather than developing locally through gradual accumulation. The Polynesian navigators possessed remarkable seafaring capabilities, crossing thousands of miles of open ocean using only stars and wave patterns for navigation, establishing settlements on remote islands scattered across the Pacific. Where did they learn these techniques? How did they develop the knowledge necessary to accomplish such extraordinary feats of navigation without instruments? The oral traditions of Polynesian cultures speak of ancestral homelands now lost beneath the sea, of great navigators who sailed from distant lands bringing knowledge and wisdom. The Easter Island Moai, those enormous stone statues that baffle archaeologists with their method of construction and transportation, show the same pattern found elsewhere. The earliest statues are often the largest and finest, with later examples showing decline in quality and size. This suggests inherited technique being gradually lost, rather than developing skill being gradually improved. The question that haunts all these threshold cultures is the same. How much did they truly understand of what they were preserving? Were they conscious inheritors, aware that they were maintaining knowledge from an earlier age, or had the original context already been lost, leaving them maintaining traditions they no longer fully comprehended, following practices whose purposes had become obscure? The evidence suggests different answers for different times and places. Some cultures, like early Egypt and Sumer, seem to have maintained conscious awareness of inheriting from predecessors. Their texts explicitly reference earlier ages and acknowledge learning from previous teachers. Other cultures, arising later or in more isolated regions, may have retained the practices while losing the origin stories, maintaining the what while forgetting the why. But whether conscious or not, these threshold watchers performed an invaluable service. They kept alive across thousands of years the fragments of pre-flood knowledge, even when those fragments had become separated from their original contexts, even when the techniques had degraded and the understanding had dimmed. They maintained astronomical observations, preserved mathematical principles, continued architectural traditions, told and retold the stories of catastrophe and survival. Without their dedication, even the fragments would have been lost. Human civilization would have had to start completely from zero, reinventing everything, with no inherited knowledge to build upon. Instead, we received an inheritance, imperfect, fragmentary, often misunderstood, but real nonetheless. The foundations were there for later civilizations to build upon. When Greek philosophers began their systematic investigations of nature and mathematics, they could draw on Egyptian and Babylonian traditions that stretched back thousands of years. When Renaissance scientists began the work that would lead to modern science, they could study ancient texts preserved through the Middle Ages, texts that contained within them knowledge originally discovered in ages before the flood. We are all threshold watchers now, standing between what was and what might be, inheriting from the past and building for the future. The knowledge we possess, accumulated across centuries of modern scientific investigation, represents a recovery and extension of principles that were perhaps known and then lost thousands of years ago. We have regained and exceeded the capabilities of the pre-flood civilization in many domains, developing technologies and understanding that our ancient predecessors did not possess. But in some ways we may still be recovering knowledge they had, and we forgot, rediscovering principles encoded in the monuments they left behind. The mathematical relationships embedded in the Great Pyramid continue to yield new insights as our measurement techniques improve and our mathematical sophistication grows. The astronomical alignments of ancient monuments reveal knowledge we are only now beginning to fully appreciate. The acoustic properties of megalithic chambers demonstrate understanding of sound and resonance that modern physics is still working to completely explain. The monuments continue to teach. The knowledge continues to emerge. The inheritance continues to unfold. And like the threshold watchers who came before us, we face the question of what we will preserve and how we will preserve it. Our knowledge exists primarily in forms dependent on continuing infrastructure and technological capability. Digital archives require electricity, functioning computers, compatible software, and cultural continuity to remain accessible. If these foundations fail, if civilization faces another catastrophe, how much of what we know would survive? What are we encoding in permanent form? What are we teaching in ways that will persist across disruption? The ancient threshold watchers provide models we might learn from. They encoded knowledge in multiple forms, in monuments, in myths, in practices, in institutions dedicated to preservation. They created redundancy, ensuring that if one method of transmission failed, others might succeed. They embedded knowledge in culture and meaning, making it valuable enough that people would work to preserve it, even when its practical applications were no longer understood. They thought across generations, building for futures they would never see. teaching for students they would never meet. We might do well to emulate their foresight, to create our own monuments encoding essential knowledge in forms that will survive technological disruption, to embed crucial information in multiple, redundant systems, to teach not just facts but principles, not just techniques but understanding, not just knowledge but wisdom, to build institutions and traditions dedicated to preservation across long time horizons, to think beyond our own lifetimes, beyond our own civilization's immediate needs, to consider what those who come after us will need to know, and how they might access it if our current systems fail. The Threshold Watchers call to us across the ages. These anonymous preservers, these patient teachers, these determined guardians of inherited knowledge. They succeeded in their mission of carrying forward through dark times the seeds of earlier wisdom. They ensured that human civilization could rebuild, rather than restart entirely from scratch. They preserved the memory of what had been lost, so that we might learn from it and perhaps, eventually, recover it. Now the responsibility passes to us. Now we are the Threshold Watchers, standing at the boundary between one age and whatever age comes next. The question is whether we will prove as dedicated, as thoughtful, as determined to preserve what matters as those who came before us. Whether we will build monuments that will teach future generations. Whether we will encode knowledge in forms that will survive catastrophe. Whether we will ensure that whatever comes after us will have the inheritance of wisdom to build upon, rather than only ruins to puzzle over. The ancient monuments stand waiting, their lessons only partially learned, their secrets only partially revealed. The threshold remains, between knowing and forgetting, between wisdom and ignorance, between inheritance and loss. And we stand at that threshold, as countless generations have stood before us, choosing what we will preserve, what we will teach, what we will pass forward into the unknown future. The Echoes of Silence. There is a peculiar quality to ruins that draws the human spirit. We stand before them, these weathered stones, these crumbling walls, these eroded monuments, and feel something stir within us that transcends mere curiosity about the past. It is a recognition, perhaps, or a remembering, a whisper from some deep place in our collective consciousness that says, these stones know something we have forgotten, that they carry within their silence answers to questions we have not yet learned to ask properly. The ruins speak, but they speak in a language we have almost lost the ability to hear. Not the literal languages inscribed on their surfaces, though those too present challenges to our understanding. Rather, they speak the older language of form and proportion, of alignment and resonance, of stone shaped by hands that understood principles we are only beginning to recover. They are echoes of a silence that fell 12,000 years ago, when the waters rose and the cities drowned, and the knowledge keepers who might have explained everything perished in the catastrophe that remade the world. What remains is fragments, pieces of a vast puzzle scattered across continents, buried under centuries of sediment, hidden beneath jungle canopy or desert sand, sometimes in plain sight, but unrecognized for what they truly represent. Each fragment carries information, but, like pieces of a shattered mirror, no single piece can reveal the whole image. We must gather them together, these scattered remnants, and attempt to reconstruct from them the face of the civilization that gazed into the mirror before it broke. Consider the enigma of Nan Madol, that mysterious complex of artificial islands off the coast of Ponape in Micronesia. Here, in one of the most remote regions of the Pacific Ocean, lie the ruins of a city built upon a coral reef, constructed from massive basalt logs weighing many tons each, stacked like cordwood to create walls and platforms and channels. The complex covers more than 170 acres, containing nearly 100 artificial islands connected by a network of canals. It has been called the Venice of the Pacific, and, like Venice, it seems to float impossibly upon the water, defying the practical difficulties that should have made its construction prohibitively difficult. The basalt used in Nan Madol's construction came from quarries on the main island of Ponape, transported several miles across water to the reef site. The largest stones weigh up to 50 tons. How were they moved? The conventional answer points to rafts and human muscle power. But this explanation grows less satisfying the more one considers the logistics. Basalt is dense, heavy, difficult to work. Moving 50-ton blocks across open water on primitive rafts would be extraordinarily dangerous and difficult. Yet hundreds of such blocks were transported and positioned with precision to create a complex that served both residential and ceremonial functions. Local tradition offers a different explanation. The stories say the stones flew through the air, moved by magic, positioned by the powers of ancient sorcerer priests who commanded forces we no longer understand. Modern researchers smile at such tales, dismissing them as fantasy and superstition. But what if the stories preserve distorted memory of actual techniques? Capabilities that seem magical to later generations who have lost the knowledge of how they were accomplished. What if the ancients possessed understanding of acoustic levitation, or magnetic manipulation, or some other principle we have not yet rediscovered, technologies that allowed them to move stones with methods that would seem impossible to those who came after? The dating of Nan Madol presents its own mysteries. Conventional archaeology places the main construction period at around 1000 to 1500 AD, relatively recent in the scope of human history. But this dating relies on artifacts found in association with the structures rather than the stones themselves, which cannot be directly dated. Local traditions speak of the site as far more ancient, claiming it was built by the Saudeleur dynasty whose origins stretch back into the mists of time. Some researchers have suggested that the basalt structures visible today might be built atop or around earlier foundations now submerged, that rising sea levels might have covered the oldest portions of the complex, leaving visible only the later additions and renovations. If Nan Madol is indeed far older than conventional dating suggests, if it represents or incorporates work from the pre-flood era, then its existence in such a remote location takes on new significance. It suggests that the maritime capabilities of the ancient world were far more extensive than we generally acknowledge, that there existed cultures capable of navigating vast distances across open ocean, establishing settlements and building substantial structures in locations that should have been beyond their reach. It suggests a level of organization and resource mobilization that contradicts our image of ancient peoples as small-scale, locally focused communities incapable of ambitious projects in remote locations. The same questions arise at other enigmatic sites scattered across the Pacific. The Ha'amonga a Maui in Tonga, a massive stone trilithon reminiscent of Stonehenge, demonstrates engineering capabilities that seem out of proportion to the resources of the small island culture credited with its construction. The platforms of Pule Malai in Samoa, the stone ruins of Rapa Nui, the extensive complexes on islands throughout Polynesia and Micronesia, all hint at capabilities and knowledge that conventional Pacific archaeology has difficulty explaining. But perhaps the most provocative evidence comes from beneath the waves. Submerged structures have been reported near various Pacific islands. Stone formations that appear too regular, too geometric, too deliberately shaped to be natural formations, yet which lie at depths suggesting they have been underwater for thousands of years. The most famous and controversial of these is the Yonaguni Monument off the coast of Japan, a massive rock formation featuring what appear to be steps, platforms, and carved surfaces. Geologists argue over whether the formation is natural or artificial, with some claiming it shows clear evidence of human modification, while others maintain it can be explained entirely through natural geological processes. The debate over Yonaguni highlights the fundamental challenge facing researchers who investigate the possibility of pre-flood civilization. The evidence is ambiguous. Natural processes can create geometric forms that look artificial. Erosion can produce right angles and flat surfaces. Underwater photography and sonar imaging can be misinterpreted. Without definitive artifacts, without tools or pottery or written records directly associated with the formations, it remains impossible to prove conclusively that they represent human construction rather than natural phenomena. Yet the absence of definitive proof does not equal proof of absence. The ocean floors remain largely unexplored. We have better maps of the surface of Mars than of the bottom of our own seas. Vast areas of continental shelf that were dry land during the Ice Age now lie under hundreds of feet of water, covered by sediment, inaccessible to archaeological investigation with current technology. If cities existed along these ancient coastlines, and there is every reason to believe they did, since coastlines have always been prime locations for human settlement, then those cities now rest where we cannot easily reach them, their ruins awaiting technology and funding sufficient to conduct proper underwater archaeological surveys.
The ruins that remain above water, accessible to investigation, represent a biased sample. They are the structures built on high ground or far inland, the monuments that were either fortunate enough to be positioned above the rising waters or were built specifically to survive catastrophe. The coastal cities, the ports and harbors, the maritime centers, were the most sophisticated and cosmopolitan aspects of ancient civilization would have flourished. These are lost to us, drowned beneath the waves, leaving only hints and suggestions of their existence. This loss of evidence has profound implications for our ability to understand the past. We are attempting to reconstruct the face of ancient civilization while looking at only a small fraction of what once existed. Like trying to understand a person by examining only their feet, while their head, torso, and arms remain hidden. We see the bottom, the foundations, the most basic and enduring elements, but the sophisticated, complex, technologically advanced aspects, the parts that would most clearly demonstrate the capabilities of the pre-flood civilization,
Those have vanished beneath the waves or decayed into nothingness, leaving barely a trace. The silence of the ruins is thus a silence created by absence as much as by time. They are silent not only because their builders are long dead and their languages lost, but because most of what they built is simply gone, removed from our ability to examine and understand. We are left with fragments and must extrapolate from these fragments to the whole, a process that inevitably involves speculation and uncertainty. Yet even within this uncertainty, patterns emerge. The same architectural techniques appearing across vast distances, the same astronomical alignments encoded in monuments separated by oceans, the same mathematical relationships embedded in structures built by cultures with no obvious means of communication, the same myths and stories told around the world, speaking of floods and destroyed civilizations and wise teachers who came from elsewhere. These patterns cannot be easily dismissed as coincidence. They suggest underlying connections, shared knowledge, common origins, a human civilization more unified and more sophisticated than conventional history acknowledges. The ruins at Tiwanaku near Lake Titicaca in Bolivia offer particularly striking evidence of this forgotten sophistication. At an altitude of nearly 13,000 feet above sea level, in one of the harshest environments humans attempt to inhabit, stand the remains of a city that demonstrates engineering and astronomical knowledge of the highest order. The Gateway of the Sun, a massive stone portal carved from a single block of andesite weighing approximately 10 tons, is covered with intricate reliefs depicting what appears to be a calendar system of remarkable complexity. The positioning of the gateway and other structures at the site shows precise astronomical alignment to solstices and equinoxes. But what is most remarkable about Tiwanaku is not merely what remains visible above ground, but what investigation has revealed about the site's true age and extent. Conventional dating places the visible ruins at around 500 to 900 AD. Attributing them to the Tiwanaku culture that flourished in that period. Yet the site shows signs of being far older. There are at least two distinct construction phases evident, with the lower, older levels demonstrating superior stonework compared to the upper, later additions. The lowest levels contain massive stones fitted with precision that the later Tiwanaku culture apparently could not match, suggesting these foundations were built by predecessors and merely incorporated into later construction. Most intriguing of all, geological evidence suggests that some of the port facilities at nearby Pumapunku were built when the water level of Lake Titicaca was significantly higher than today, possibly hundreds of feet higher. The lake has been slowly evaporating for thousands of years as the climate has changed. For port facilities to make sense at their current elevation, they would need to have been built when the lake level was much higher, which pushes their construction date back thousands of years beyond the conventional timeline, into the period immediately following the end of the Ice Age. If the earliest construction at Tiwanaku and Pumapunku dates to the period just after the catastrophe, then these sites become yet more evidence of survivors from the pre-flood civilization establishing themselves in new locations, building monuments using inherited knowledge and techniques. The choice of such a high, harsh location might seem strange, until one considers that high altitude would have provided protection from flooding, that the survivors might have deliberately sought out elevated locations, far from coasts and major rivers, places where they could rebuild with some assurance that the waters would not reach them. The same logic might explain other mysterious high-altitude sites, like Machu Picchu in Peru, or the monasteries of Tibet. These are not locations one chooses for comfort or convenience. They are refuges, places deliberately selected for their remoteness and difficulty of access. Places where knowledge might be preserved, away from the chaos and destruction of lower elevations. The architectural sophistication visible at these sites suggests they were not built by simple mountain dwellers, but by people who brought with them knowledge from elsewhere, who possessed capabilities that allowed them to work stone with precision despite the challenging environment and limited resources. The ruins continue to yield their secrets slowly, grudgingly, as new techniques of investigation become available. Ground-penetrating radar reveals structures buried beneath sand and soil, suggesting that what we see on the surface represents only a small fraction of what exists. Satellite imagery using various wavelengths of light exposes patterns invisible to the naked eye, showing ancient roads and irrigation systems and settlement patterns that conventional archaeology had missed. DNA analysis of ancient remains reveals population movements and relationships that challenge traditional models of human migration and cultural development. Each new technique, each new discovery, adds pieces to the puzzle. But the puzzle is vast, its pieces scattered across the globe and buried under millennia of accumulated time. We have barely begun to assemble it, barely started to see the image it will reveal when enough pieces have been gathered and properly positioned. What we can see already suggests a picture very different from the one presented in conventional history textbooks. A portrait of human civilization that extends far back beyond 6,000 years, that achieved heights we are only beginning to appreciate, that possessed knowledge and capabilities we have underestimated or dismissed. The silence of the ruins is not empty. It is pregnant with meaning, heavy with untold stories, resonant with knowledge waiting to be recovered. We must learn to listen more carefully, to observe more closely, to question more boldly. We must be willing to consider possibilities that challenge established narratives, to follow evidence even when it leads to uncomfortable conclusions, to admit that what we do not know vastly exceeds what we do know about the human past. The stones remember, even when we have forgotten. The monuments preserve, even when written records have perished. The ruins speak, even through the silence of 12,000 years. They tell us that we are older than we thought, that our ancestors were more capable than we believed, that the story of human civilization is longer and stranger and more mysterious than the simplified versions we tell ourselves. They remind us that knowledge can be lost as well as gained, that civilizations can fall as well as rise, that what seems permanent can prove surprisingly fragile when the earth shakes, or the waters rise, or the sky falls. And perhaps most importantly, they whisper to us across the ages that we should not be so confident in our own permanence, so certain that our civilization is immune to the forces that destroyed what came before. The ruins stand as warnings as well as wonders, cautioning us that we too might become ruins, that our glass towers and steel bridges and digital archives might prove as vulnerable to catastrophe as the stone monuments of our ancestors proved vulnerable to flood and time.
They ask us to consider what will remain of our civilization if disaster strikes, what legacy we will leave for those who come after, whether we are building anything that will endure long enough to teach future generations what we learned and what we achieved. The echoes of silence carry these questions forward, generation after generation, asking each age to consider its relationship to past and future, to acknowledge its place in the long chain of human civilization that stretches back into the mists of time and forward into an uncertain tomorrow. The ruins ask us to remember, even as they remind us how easily everything can be forgotten. They ask us to preserve, even as they demonstrate how little of the past has successfully been preserved. They ask us to learn from what came before, even as they show us how difficult it is to recover knowledge once it has been lost. The silence speaks for those with ears to hear. The ruins teach for those with eyes to see. The stones remember for those with minds willing to listen. And the great question of our age is whether we will prove worthy students of these ancient teachers, whether we will learn the lessons encoded in the monuments and myths, whether we will take seriously the warnings and opportunities they present. The echoes fade, but do not disappear. They reverberate through time, waiting for each new generation to discover them, to interpret them, to carry them forward into whatever age comes next. We are the latest listeners to these echoes, the most recent students of these stone teachers. What we do with what they tell us will determine not only how we understand the past, but how we prepare for the future. The mathematics of remembrance. There exists a form of memory that transcends individual consciousness, that persists through generations even when specific details fade, that encodes itself not in neural pathways, but in cultural practices, architectural forms, and mathematical relationships. This is the memory carried by civilizations rather than individuals, the collective remembrance that shapes how societies organize themselves, what they build, what they value, what they preserve. It is this civilizational memory that the pre-flood survivors encoded into their monuments, hoping that even when the reasons were forgotten, the forms themselves would persist, carrying forward information to distant descendants who might eventually rediscover what the forms meant. Mathematics served as the primary language for this encoding because mathematics is universal and eternal. A geometric ratio remains true regardless of culture, language, or era. The relationship between a circle's diameter and circumference, pi, exists independent of human awareness or understanding. The golden ratio appears in nature whether or not humans recognize it. Prime numbers follow their patterns across all possible number systems. Mathematical truth transcends cultural boundaries in ways that human languages cannot, making mathematics the ideal medium for communicating across vast spans of time to audiences whose languages and cultures cannot be predicted. The Great Pyramid embodies this mathematical encoding at multiple scales and in multiple ways. We have already discussed how its perimeter-to-height ratio encodes pi, how its proportions incorporate the golden ratio, how its dimensions relate to the size of the Earth. But the mathematical relationships go deeper and become more intricate the more closely they are examined. The pyramid's slope angle, approximately 51.84 degrees, is not arbitrary.
This angle naturally emerges when you construct a pyramid whose height equals the radius of a circle, whose circumference equals the pyramid's perimeter. In other words, the pyramid's shape encodes the relationship between linear and circular measurement, between straight edges and curves, between discrete and continuous geometry. The internal chambers and passages of the pyramid demonstrate equally sophisticated mathematical design. The Grand Gallery rises at an angle that relates to both solar and stellar alignments. Its length can be measured in units that relate to important astronomical periods: the precession of the equinoxes, the cycle of solar eclipses, the orbital periods of planets. The King's Chamber proportions follow Pythagorean relationships, with its length, width, and height forming ratios that can be expressed as simple whole numbers whose squares relate to each other in elegant ways. These are not decorative choices, but functional design principles, embedding information in the very structure of the spaces. Some researchers have suggested the pyramid functions as a three-dimensional mathematical textbook, with different chambers and passages encoding different theorems and relationships. Measure the passages in the right units and you find the speed of light. Calculate the ratios between different chambers and you discover relationships between Earth and Moon sizes. Analyze the angles and you find astronomical constants. Whether all these relationships are intentional or some are coincidental remains debatable, but the sheer number and precision of the mathematical properties suggests deliberate encoding rather than accident. Consider what this means for our understanding of ancient mathematical knowledge. If the pyramid was built around 2500 BC, as conventional chronology claims, then Bronze Age Egyptians possessed mathematical sophistication far beyond what conventional history attributes to them. They would have known pi and phi, understood solid geometry, grasped relationships between linear and circular measurement, comprehended astronomical periods and celestial mechanics, all without the benefit of modern instruments, computers, or accumulated millennia of mathematical development. The conventional explanation strains credulity. The alternative, that the mathematical knowledge was inherited from an earlier civilization, that the pyramid builders were working from templates and principles discovered long before, makes the achievement more comprehensible. They were not discovering these mathematical relationships, but applying them, not inventing these geometric principles, but implementing them. The knowledge came from elsewhere, from earlier, from the survivors of the catastrophe, who carried in their minds the accumulated mathematical wisdom of their lost civilization. The same mathematical sophistication appears at other ancient sites around the world. Stonehenge encodes relationships between solar and lunar cycles, allowing prediction of eclipses through careful observation of shadows and alignments. The layout of the stones follows geometric principles that can be used to generate Pythagorean triples, sets of three numbers that form right triangles. The distances between certain stones relate through ratios involving square roots of prime numbers, mathematical relationships that should not have been known to Neolithic peoples working without written number systems. At Teotihuacan in Mexico, the entire city plan demonstrates mathematical precision. The Pyramid of the Sun and Pyramid of the Moon are positioned according to geometric relationships that incorporate the golden ratio. The Avenue of the Dead runs at an angle precisely aligned to certain stellar risings. The distances between major structures follow mathematical ratios that some researchers have suggested encode the orbital periods of planets in the solar system. Whether the city's designers actually intended to encode planetary orbits remains uncertain, but the mathematical relationships exist regardless, suggesting knowledge of celestial mechanics and geometric principles. The Inca quipu, those mysterious knotted strings used for record-keeping, represent another form of mathematical encoding. Each knot's position, type, and relationship to other knots carried information, creating a three-dimensional writing system based entirely on mathematical relationships. The Spanish conquistadors destroyed most quipus they encountered, considering them instruments of devil worship, leaving only a few hundred surviving examples. Modern researchers have partially decoded the system, discovering that quipus recorded not just numbers, but narrative information, encoding stories and genealogies and historical records in mathematical form. But the full complexity of the system remains poorly understood, its complete decoding hampered by the loss of cultural context and the destruction of most examples. What makes the quipu particularly intriguing is that it represents a completely different approach to information encoding than alphabetic writing. Rather than using symbols that represent sounds or ideas, the quipu uses mathematical relationships, position, number, ratio, to carry meaning. This suggests the Inca, or their predecessors who developed the system, understood that mathematics itself could serve as a language, that information could be encoded in numerical and geometric relationships as effectively as in written words. Whether this understanding was an indigenous development or inherited knowledge from earlier sources remains unknown, but it demonstrates a sophistication of thought that challenges conventional assumptions about ancient intellectual capabilities. The mathematical encoding extends beyond monumental architecture into smaller artifacts and artistic expressions. The Antikythera mechanism, that extraordinary bronze device recovered from a Mediterranean shipwreck, demonstrates mechanical computation of astronomical positions, using precisely crafted gears with tooth counts chosen to represent the ratios between different celestial cycles. Creating such a device required not only mathematical knowledge of orbital periods, but also sophisticated metallurgy, precision manufacturing, and mechanical engineering understanding. The device dates to around 100 BC, yet nothing of comparable complexity appears in the historical record again until medieval astronomical clocks, more than 1,000 years later. How did the makers of the Antikythera mechanism acquire the knowledge to build it? The conventional answer points to Greek astronomical and mathematical developments during the Hellenistic period, but the device seems too sophisticated to be a first attempt, suggesting a tradition of mechanical computation that stretched back earlier, but left few other traces in the archaeological record. Perhaps such devices were common at one time, but being made of metal, they corroded away or were melted down for their material value, leaving only this single example preserved by lucky accident in an ancient shipwreck. Or perhaps the Antikythera mechanism represents recovered knowledge from much earlier, an attempt to recreate devices that had existed in the pre-flood civilization, but whose manufacturing techniques had been largely lost. The Greeks were recovering knowledge from Egyptian sources, and the Egyptians claimed their wisdom came from the first time, the age before the flood. Perhaps mechanical astronomical computers existed in that lost age, were destroyed in the catastrophe, and then slowly, partially recreated by later cultures working from fragmentary records and inherited principles. The mathematical encoding found in ancient art and symbolism suggests knowledge being preserved in cultural forms that could survive the loss of specialized institutions. The flower of life pattern appears carved into Egyptian temples, Chinese artwork, and Irish illuminated manuscripts. This simple geometric pattern, formed by overlapping circles in a hexagonal array, contains within it the basic forms from which all the Platonic solids can be derived. It is a compact geometric code, carrying complex three-dimensional information in two-dimensional form. Anyone who understood the pattern could use it to generate sophisticated geometric relationships without requiring written instructions or mathematical texts. The same principle appears in other geometric patterns found across ancient cultures. The Sri Yantra of Hindu tradition, the labyrinth patterns found from Crete to Scandinavia to the Americas, the intricate knots of Celtic art, all encode mathematical relationships in visual form, preserving geometric knowledge in symbols that could be reproduced and studied even when the theoretical understanding behind them had faded. The patterns functioned as memory aids, as teaching tools, as cultural carriers of mathematical principles that might otherwise have been forgotten. This approach to knowledge preservation makes particular sense in the context of catastrophic collapse. When libraries burn and specialists die and institutions fail, what survives are the most widely distributed, most culturally embedded forms of knowledge. A geometric pattern carved into a temple wall, reproduced in artwork, woven into textiles, drawn by children learning the traditions of their elders, such a pattern has redundancy and persistence that fragile texts and specialized knowledge cannot match. If the goal is to preserve information across catastrophe and civilizational collapse, encoding it in widely distributed cultural forms makes strategic sense. The ancient mystery schools understood this principle. They taught mathematics not as abstract theory but as sacred geometry, embedding mathematical principles in ritual and symbol, connecting geometric relationships to cosmological meanings, making mathematics memorable and meaningful rather than merely technical. The Pythagorean emphasis on number as the fundamental nature of reality was not primitive numerology, but sophisticated philosophy recognizing that mathematical relationships underlie physical phenomena. By treating mathematics as sacred, the Pythagoreans ensured it would be valued, protected, transmitted carefully across generations. The same approach appears in other traditions. The Vedic mathematicians of India embedded mathematical principles in poetic verse, creating texts that could be memorized and recited, that pleased the ear while conveying precise numerical information. The verse form provided error checking. If a syllable count was wrong, the rhythm would be off, alerting the reciter that something had been corrupted. This technique preserved mathematical knowledge across centuries with remarkable accuracy, maintaining precision through oral tradition in ways that written texts subject to copying errors could not match. The Maya mathematical system, with its sophisticated concept of zero and its positional notation allowing calculation of enormous numbers, was embedded in calendrical and astronomical contexts that gave it cultural meaning beyond mere utility. The mathematics served religious purposes, tracking the cycles of divine time, predicting celestial events that had spiritual significance. By connecting mathematics to religion and cosmology, the Maya ensured that mathematical knowledge would be valued and preserved by priestly specialists,
dedicated to maintaining the sacred traditions. All these approaches to mathematical preservation suggest lessons learned, techniques refined through experience, strategies developed by cultures that understood knowledge could be lost and therefore needed to be encoded in multiple redundant forms with multiple layers of meaning. The sophistication of these preservation strategies itself suggests inherited wisdom, lessons passed down from predecessors who had experienced catastrophic loss and developed techniques to prevent such loss from erasing knowledge entirely. We who live in an age of printed books and digital archives may think the problem of knowledge preservation has been solved. But our forms of preservation are more fragile than we generally acknowledge. Digital storage requires electricity, functioning hardware, compatible software, and cultural continuity. A solar flare, an electromagnetic pulse, a civilizational collapse that interrupts power generation would render digital archives inaccessible within days or weeks. Printed books are more durable but still vulnerable to fire, flood, decay, and simple loss through the disruption of distribution networks.
The ancient approach, encoding knowledge in stone, embedding it in widely distributed cultural practices, connecting it to meaning and value that ensures preservation, may prove more durable than our supposedly advanced techniques. When the power fails and the servers go dark and the books burn, what will remain? What are we encoding in truly permanent form? What knowledge are we embedding in culture deeply enough that it will survive disruption? The mathematics of remembrance is not just about numbers and ratios and geometric relationships. It is about understanding how knowledge persists across time. What forms of encoding survive catastrophe? What strategies maximize the probability that crucial information will reach distant descendants? The ancients mastered this mathematics through hard experience, through watching knowledge fade and be lost, through desperate efforts to preserve what mattered most. Their monuments stand as solutions to the equation of remembrance, as physical embodiments of knowledge preservation strategies refined across generations. The mathematical relationships encoded in the pyramids and megaliths and stone circles are not merely interesting curiosities, but functional information storage, data encoded in the most durable possible form, designed to survive millennia and communicate to audiences separated by vast cultural and temporal distances. We are only beginning to decode these messages, only starting to appreciate the full sophistication of what the ancient builders achieved. Each new measurement, each new analysis, each new mathematical relationship discovered in the monuments reveals another layer of encoded information, another aspect of the wisdom our ancestors were desperate to preserve. The mathematics speaks across 12,000 years, carrying forward principles and knowledge and warnings encoded by survivors determined that their descendants would not have to rediscover everything from scratch. The question now is whether we will complete the decoding, whether we will fully recover the knowledge the monuments preserve, whether we will learn the lessons encoded in stone and number and geometric form, and whether we will apply those lessons to our own situation, creating our own monuments and encodings that will preserve what we have learned for whatever generations come after us. The mathematics of remembrance demands we think across deep time, plan for scenarios we hope will never occur, encode what matters most in forms that will endure, when everything else fails. The ancient builders understood this necessity. They lived it. They built according to its principles. Now their monuments ask us whether we understand it too, whether we grasp the fragility of knowledge and civilization, whether we will take responsibility for preserving what matters for the future. The mathematics waits in stone, patient and eternal, carrying its message across the ages to any who learn to read it. The cartographers of lost worlds. There are maps that should not exist, charts that depict coastlines as they were thousands of years before any civilization we acknowledge could have mapped them. Portolans showing longitude calculated with precision that would not be achieved again until the 18th century. Documents that render Antarctica without its ice, displaying geographical features buried under mile-thick glaciers for at least 6,000 years, possibly much longer. These impossible maps exist in our archives and libraries, copied and recopied across centuries, their origins lost in time, their accuracy inexplicable by conventional historical understanding. The most famous of these anomalous charts is the Piri-Reis map, drawn in 1513 by the Ottoman admiral and cartographer Piri-Reis. The map shows the Atlantic Ocean, the coasts of Africa and South America, and curiously the northern coast of Antarctica. What makes the map remarkable is not merely that it shows Antarctica, a continent that would not be officially discovered until 1820, but how it shows it. The coastline depicted on the Piri-Reis map matches not the ice-covered Antarctica we know, but the actual rocky coastline beneath the ice, features that were only discovered in 1949, when seismic profiling first revealed the true topography hidden under the glaciers. Piri-Reis himself noted on the map that he compiled it from approximately 20 source maps, some dating from the time of Alexander the Great or earlier. He claimed access to ancient charts preserved in the Imperial Library at Constantinople, documents that had been collected from various sources over centuries. The implication is staggering that somewhere in the ancient world, at a time when conventional history claims no civilization possessed the capability for such exploration, someone mapped Antarctica while it was at least partially ice-free, and that knowledge was somehow preserved through the millennia and eventually copied onto Piri-Reis's chart. The conventional explanation attempts to dismiss the map's accuracy as coincidental, suggesting that what appears to be Antarctica is actually a misdrawn extension of South America, that the resemblance to the ice-free coastline is merely pareidolia, seeing patterns where none exist. But this explanation grows less convincing when one examines the map in detail. The general shape, the placement of bays and peninsulas, the overall configuration, all correspond better to Antarctica's actual topography than to an imaginative extension of South American geography. Moreover, the Piri-Reis map is not alone. Other ancient and medieval maps show similar anomalies. The Orontius Phineus map of 1531 depicts Antarctica as ice-free, showing rivers, mountains, and coastal features in remarkable detail. The Buash map of 1737, though much later, claims to be based on ancient sources and shows Antarctica as two large islands separated by a sea, which is essentially correct, as the continent is indeed divided by a channel that would become an ice-free strait
if the massive weight of glacial ice were removed. The Mercator map of 1569 shows Arctic regions with accuracy that should have been impossible given the navigational capabilities of the time, depicting islands and coastlines in the far north that were only rediscovered and accurately mapped in the 20th century. These maps suggest the existence of an ancient maritime culture, possessing sophisticated navigational capabilities, the ability to determine longitude accurately, and the resources to mount extensive exploratory expeditions to the most remote regions of the planet. Such a culture would need to have existed during a period when Antarctica was at least partially ice-free, which places it before approximately 4000 BC at the latest, possibly much earlier, depending on which glaciation models one accepts. This time frame aligns perfectly with the catastrophe that ended the Ice Age around 12,000 years ago, suggesting the maps preserve geographical knowledge from the pre-flood civilization. How did these ancient cartographers determine longitude? This problem vexed European navigators for centuries. Latitude can be determined by measuring the angle of the sun or particular stars above the horizon, a relatively simple calculation requiring only basic instruments. But longitude requires accurate timekeeping, the ability to compare local time determined by solar position with a reference time at a known location, usually a prime meridian. The difference in time translates to difference in longitude. European sailors did not solve this problem until the development of accurate marine chronometers in the 18th century, precise clocks that could maintain accuracy despite the motion and temperature variations experienced on sailing ships. Yet the ancient maps show longitude calculated correctly, coastlines positioned with accuracy that requires precise knowledge of their longitudinal positions. This implies either that the ancient cartographers possessed accurate timekeeping devices, mechanical or astronomical, or that they used some alternative method for determining longitude that we have not yet identified. Either possibility suggests technological and scientific sophistication far beyond what conventional history attributes to ancient civilizations. The ancient maps also demonstrate knowledge of cartographic projection, the mathematical techniques required to represent the curved surface of a spherical Earth on a flat map. Different projection methods preserve different properties. Some maintain accurate angles. Others preserve areas. Still others minimize distortion of distances. The choice of projection and its correct mathematical implementation requires understanding that the Earth is spherical and sophisticated mathematics to handle the geometric transformations involved. The ancient maps show evidence of various projection techniques, suggesting their creators understood these principles and chose appropriate methods for their purposes. The Portolan charts of the Mediterranean, which appear suddenly in the 13th and 14th centuries with no clear developmental history, demonstrate particularly remarkable accuracy. These charts show coastlines, harbors, and navigational routes with precision that equals or exceeds modern coastal surveys. The distances and angles are correct, the positions of geographical features accurate. Yet they appear fully formed, without the expected progression from crude early attempts to refined later versions. It is as if someone already possessed accurate maps and the Portolan charts merely copied this earlier information. Medieval and Renaissance cartographers themselves
sometimes acknowledged they were working from ancient sources. Claudius Ptolemy's geography, compiled in the 2nd century AD, claims to be based on much earlier maps and geographical knowledge. Ptolemy provided coordinates for thousands of locations across the known world, latitudes and longitudes calculated with systematic precision. Where did Ptolemy obtain this information? He cites various sources, some predating him by centuries. The implication is that geographical knowledge had been accumulated over a long period, perhaps reaching back to sources from before the rise of classical civilization. The question of how pre-flood civilizations might have mapped the entire world raises interesting logistical considerations. Mapping requires extensive travel and systematic surveying. For a maritime culture, this would mean ships capable of long-distance ocean travel, navigational techniques allowing accurate position finding, and the organizational capacity to coordinate expeditions spanning years or decades. All of this was supposedly beyond ancient capabilities. Yet if the maps are genuine copies of ancient sources, then clearly these capabilities did exist, even if we do not understand how they were achieved. Perhaps the pre-flood civilization possessed vessels more sophisticated than we imagine. The largest wooden ships we know how to build reach about 300 feet in length before structural limitations make them impractical. But perhaps ancient shipbuilders understood techniques we have forgotten, ways of bracing and reinforcing hull structures that allowed larger vessels. Perhaps they used different materials, composite constructions combining wood with other substances, that provided strength without the weight penalties of purely wooden construction. Perhaps they understood hydrodynamic principles that allowed more efficient hull designs, ships that could travel faster and farther with less effort. The ancient maps sometimes show features that suggest advanced surveying techniques. Some researchers have noted that certain medieval maps appear to be compiled from aerial views, as if someone had observed the terrain from high altitude and sketched the patterns they saw. The famous Nazca lines in Peru make most sense when viewed from the air, yet supposedly were created by people who could not fly. What if flight was possible in the ancient world, not through modern aviation technology, but through lighter-than-air craft, hot air balloons, or dirigibles constructed from materials available to ancient peoples? Such craft would leave little archaeological trace. Fabric and rope decay completely, but would explain how ancient surveyors might have achieved the perspective necessary for accurate mapping of large areas. The maps may also preserve memory of different coastlines and sea levels. During the Ice Age, when vast quantities of water were locked in glaciers, sea levels were hundreds of feet lower than today. Coastlines extended far beyond their current positions. What is now sea floor was dry land. The Mediterranean basin contained less water and may have been divided into several separate seas. The Persian Gulf was a river valley. The English Channel did not exist. Indonesia formed a single massive subcontinent rather than an archipelago of islands. Some ancient maps show geographical features consistent with these lower sea levels. They depict islands that no longer exist, coastlines that extend beyond current shores, rivers that once flowed across what is now sea floor. If these maps are based on surveys conducted before sea levels rose, they would naturally show geographical features that later became submerged. The gradual copying and updating of these maps across thousands of years would explain why some features are accurately depicted, while others have been corrupted or misunderstood by copyists who no longer recognized what they represented. The implications extend beyond simple geographical curiosity. If there existed a pre-flood civilization capable of mapping the entire world, then that civilization must have been global in extent, or at least global in reach. They must have possessed the organizational sophistication to coordinate mapping expeditions across decades or centuries. They must have valued geographical knowledge enough to invest enormous resources in acquiring it. They must have had reasons, trade, exploration, strategic planning, that made such knowledge valuable enough to justify the effort required to obtain it. This suggests a level of cultural and technological development that matches or exceeds many aspects of our own civilization. We pride ourselves on having mapped the world, on possessing geographical knowledge of every coastline and continent. But if the ancient maps preserve genuine information from 12,000 years ago, then we are not the first culture to achieve this. We are merely recovering knowledge that was once possessed and then lost, rediscovering what our distant ancestors already knew. The loss of this geographical knowledge in the catastrophe would have been devastating for any maritime civilization. Navigation without accurate maps is dangerous and difficult. Trade routes would have been disrupted. Connections between distant regions would have been severed. The survivors would have found themselves isolated, cut off from the global network that had previously bound their civilization together. They would have retained perhaps fragmentary coastal knowledge of their immediate regions, but the comprehensive global perspective would have been lost, preserved only in copies of ancient charts, whose full context and meaning gradually faded. We can imagine the knowledge keepers after the flood gathering whatever maps survived, attempting to preserve them, copying them carefully, passing them forward to descendants who might eventually be able to use them again. But with each copying, errors would creep in. Features would be misunderstood. Scales would be corrupted. Coastlines would be simplified or exaggerated. The maps would become less accurate, more stylized, until eventually they might be dismissed as imaginative rather than representational, as mythological geographies rather than attempts to depict actual places. This may explain the curious mixture of accurate and inaccurate information found in ancient and medieval maps. They preserve genuine geographical knowledge from ancient sources, but that knowledge has been corrupted by generations of copying, by the addition of legendary locations and imaginary islands, by the attempts of later cartographers to reconcile ancient charts with their own more limited geographical knowledge. The result is maps that contain both remarkable accuracy and obvious errors, both genuine information and clear fiction. The challenge for modern researchers is to separate the genuine from the corrupted, to identify which features of ancient maps represent real geographical knowledge and which are later additions or misunderstandings. This requires careful comparison of ancient charts with modern geographical data, analysis of cartographic techniques to determine which elements are most likely to be original, and consideration of what geographical knowledge would have been most valuable to ancient civilizations, and therefore most likely to be carefully preserved. Some researchers have used computer analysis to test the accuracy of ancient maps, digitizing the coastlines and comparing them to modern surveys. The results often show surprising correlation, with ancient charts matching modern geography far better than chance would allow. suggesting they are based on actual surveying data, rather than imagination or myth. Other researchers have examined the mathematical properties of ancient maps, analyzing their projection methods and coordinate systems, finding sophistication that should not have existed at the times the surviving copies were made. The ancient maps force us to reconsider our assumptions about the capabilities of past civilizations. If they possessed the navigational technology to reach and accurately map Antarctica, what else might they have achieved? If they understood cartographic projection and longitude calculation thousands of years before we supposedly discovered these techniques, what other knowledge might they have possessed that we have attributed to later discovery? If they valued geographical knowledge enough to undertake the enormous effort required to map the entire world, what kind of civilization were they? What motivated them? What were their priorities and goals? These questions cannot be definitively answered with the evidence currently available. The maps exist. Their accuracy is demonstrable, but their origins remain shrouded in uncertainty. We have copies of copies, reproductions made centuries after the originals, with no clear chain of transmission back to the source. We can analyze what survives, but we cannot fully reconstruct what has been lost. We can recognize sophistication, but we cannot completely understand the methods that produced it. Yet the maps themselves speak, as the monuments speak, as the mathematical relationships speak. They tell us that human knowledge is older than we thought, that capabilities we consider modern may have ancient precedents, that the story of discovery and invention may be as much about recovery and remembering as about original creation. They suggest that we stand not at the pinnacle of human achievement, but at a point in a much longer cycle, recovering knowledge our ancestors once possessed, relearning what was forgotten, remapping a world that was perhaps already mapped 12,000 years ago. The cartographers of the lost world sail in our imagination, navigating uncharted seas, surveying distant coastlines, carefully recording their observations so that others might follow. They mapped not just geography, but possibility, not just coastlines, but human potential. They demonstrated that comprehensive knowledge of the world was achievable, that no region was too remote, that systematic observation and careful recording could produce understanding on a global scale. Their maps survived, fragmentary and corrupted, but recognizable, carrying forward across the catastrophe the message that the world had been known, had been charted, had been understood. And implicitly, they carried forward the challenge to their descendants to reclaim that knowledge, to remap what was lost, to recover the global perspective that the flood had swept away. We who now possess satellites and sonar and computer mapping may think we have exceeded their achievements, but perhaps we have merely recovered what they already knew, reclaimed what was lost, returned to a level of geographical understanding that existed long before recorded history began. The impossible maps wait in archives, their secrets still only partially decoded, their origins still mysterious. They ask us to reconsider what we think we know about the past, to question assumptions about ancient capabilities, to recognize that history may be far stranger and more complex than conventional narratives suggest. They are fragments of a lost world, pieces of evidence that someone, somewhere, sometime in the deep past, possessed knowledge and abilities we have only recently recovered. And they remind us that knowledge is fragile, that civilizations fall, that even comprehensive understanding of the entire world can be lost if catastrophe strikes and preservation fails. The cartographers of lost worlds left us these fragments, these maps that should not exist, these impossible documents that force us to reconsider everything we thought we knew about human history. They are calling to us across the ages, asking us to remember, challenging us to understand, inviting us to recognize that we are not the first to map the world, but perhaps merely the latest in a long line of civilizations that rose, achieved comprehensive knowledge, and then, through catastrophe or decline, lost what they had gained. The question they pose is whether we will do better, whether we will preserve what we have learned in forms that will survive whatever catastrophes the future holds, whether we will ensure that the next cycle of human civilization will not have to begin from zero, but can build upon the foundation we leave them.